8th grade, Unit 5, Lesson 1, Inputs and Outputs. If you're not already a subscriber, now's a good time to hit that subscribe button. I appreciate it. Given the rule, complete the table for the function rule for the following input values. First, let's look at the function rule. The function rule is divide by 4, then add 2. When the input is 0, that means that we're going to put 0 into the function rule. 0 divided by 4 is 0, then add 2. 0 plus 2 is 2. 0 goes in and a 2 comes out. Now the input is 2. Let's put a 2 inside. 2 divided by 4 equals 2/4 or 1/2. Then add 2. 1/2 plus 2 is 2.5. A 2 goes in and a 2.5 comes out. 4 divided by 4 is 1. 1 plus 2 is 3. 6 divided by 4 is 6/4 or 1.5. 1.5 plus 2 is 3.5. 8 divided by 4 is 2. 2 plus 2 is 4. 10 divided by 4 is 10/4 or 2.5. 2.5 plus 2 is 4.5. Problem number 2. Here is an input-output rule. Write 1 if the input is odd. Write 0 if the input is even. Complete the table for the input-output rule. When the input is -3, that's odd. So we're going to write 1 for the output. When the input is -2, that's even. So we're going to write 0 for the output. When the input is -1, that's odd. I'll write 1 for the output. When the input is 0, the output is 0. When the input is +1, that's odd. I'll write 1 for the output. When the input is 2, that's even. I'll write 0 for the output. When the input's 3, that's odd. I'll write 1 for the output. Problem number 3, from 8th grade, Unit 4, Lesson 15. Andre's school orders some new supplies for the chemistry lab. The online store shows a pack of 10 test tubes costs $4 less than a set of nested beakers. In order to fully equip the lab, the school orders 12 sets of beakers and 8 packs of test tubes. A. Write an equation that shows the cost of a pack of test tubes, T, in terms of the cost of a set of beakers, B. A pack of test tubes is $4 less than a set of beakers. The equation would read T equals B minus 4. B. The school office receives a bill for the supplies in the amount of $348. Write an equation with T and B that describes this situation. The bill for $348 represents the cost of the test tubes and the cost of the beakers. 8 sets of test tubes and 12 sets of beakers cost $348. So the equation reads 8T plus 12B equals 348. C. Since T is in terms of B from the first equation, this expression can be substituted into the second equation, where T appears. Write an equation that shows this substitution. In green, we have the first equation that shows the value for T. T equals B minus 4. We can substitute the T from the second equation with B minus 4. So now it reads 8 times B minus 4 plus 12B equals 348. D. Solve the equation for B. Use the distributive property to multiply 8 times B, that's 8B, and 8 times a -4, that's a -32. Bring down the positive 12B, bring down the equal sign, and bring down 348. Collect like terms. 8B plus 12B is 20B. Bring down the -32, bring down the equal sign, and bring down 348. Now the equation reads 20b minus 32 equals 348. add 32 to both sides. Negative 32 plus 32 cancels each other out, and 348 plus 32 equals 380. Now the equation reads 20b equals 380. Divide both sides by 20. 20b divided by 20 equals 1b, or b, and 380 divided by 20 equals 19. b equals 19. E. How much did the school pay for a set of beakers? And how much did they pay for a pack of test tubes? One set of beakers cost $19. Let's find out how much they paid for a pack of test tubes. Let's use this equation, 8t plus 12b equals 348. And let's solve for t. Since b equals 19, we can substitute the b with a 19. 12 times 19, that's 228. So they spent $228 on beakers. Subtract the price for beakers from both sides. 228 minus 228 cancels each other out, and 348 minus 228 is 120. 8 packs of test tubes cost $120. How much for one pack of test tubes? Divide both sides by 8. 8t divided by 8 is 1t, or t. And 120 divided by 8 is 15. One pack of test tubes costs $15. Problem number 4 from 8th grade, Unit 4, Lesson 14. Solve y equals x minus 4 and y equals 6x minus 10. We can use this first equation, y equals x minus 4. So let's plug that into this second equation. Where it says y equals 6x minus 10, substitute the y with an x minus 4. So now it reads x minus 4 equals 6x minus 10. We can solve for x by subtracting x from both sides. X minus x, or 1x minus 1x, and 6x minus x. 1x minus 1x cancels each other out, and 6x minus 1x is 5x. To get the term with the x in it by itself, we have to get rid of the negative 10, and we do that by adding 10 to both sides. Negative 10 plus 10, that's the same as 10 minus 10, they cancel each other out. Negative 4 plus 10, that's the same as 10 minus 4, that's 6. So now the equation reads 6 equals 5x. To find the value for 1x, we have to divide both sides by 5. 5x divided by 5 is 1x, or x, and 6 divided by 5 is 6/5. X equals 6/5. Now that we know the value for x, we can substitute the variable x with 6/5. So now the equation reads y equals 6/5 minus 4. To find the value for y, I need to subtract 4 from 6/5. I'm going to do that by making their denominators the same. 1 times 5 equals 5, and since I made the denominator 5 times bigger, I need to make the numerator 5 times bigger. 4 times 5 equals 20. So the equation reads y equals 6/5 minus 20/5. Since 6 minus 20 is negative 14, then y equals negative 14/5. Problem number 5 from 8th grade, Unit 4, Lesson 9. For what value of x do the expressions 2x plus 3 and 3x minus 6 have the same value? Let's find out. 2x plus 3 equals 3x minus 6. Let's solve for x. Subtract 2x from both sides. 2x minus 2x cancels each other out, and 3x minus 2x is 1x, or x. Now to get the x by itself, we have to get rid of the negative 6, and we'll do that by adding 6 to both sides. Negative 6 plus 6 cancels each other out, and 3 plus 6 is 9. X equals 9. Both expressions have the same value when x is 9. Substitute 9 for x and test it out for yourself. 2 times 9 plus 3, and 3 times 9 minus 6. 8th grade, Unit 5, Lesson 2, Introduction to Functions. Problem number 1. Here are several function rules. Calculate the output for each rule when you use -6 as the input. A. -6 is the input. The function is subtract 7. -6 minus 7. The output is -13. B. -6 is the input. The function is square the input, so -6 squared, or -6 times -6. The output is 36. -6 is the input. The function is divide by 3. -6 divided by 3. The output is -2. The input is -6. The function is divide the input into 3. That means how many times does -6 go into 3? Or 3 divided by -6. The output is -1/2. The input is -6. The function is write pi. The output is pi. So when a -6 goes in, a pi comes out. The input is -6. The function is find the volume of a cube where the side length is equal to the input in centimeters. That's an error because a side length can't be a negative number. Problem number 2. A group of students is timed while sprinting 100 meters. Each student's speed can be found by dividing 100 meters by their time. Is each statement true or false? Explain your reasoning. A. Speed is a function of time. Let's just say the time for one of the runners was 60 seconds. 100 meters divided by 60 seconds would equal 5/3. If the input was 60 seconds and the function was 100 divided by the input, the output would be 5/3 meters per second. Imagine the input was 30 seconds. The function would be 100 divided by the input, and the output would be 10/3. That would mean that the speed would be 10/3 meters per second. This is true. Speed is a function of time. B. Time is a function of distance. Imagine the input is distance, and the distance was 100 meters for all the runners. If the time for one runner was 22 seconds, and the second runner's time was 30 seconds, and the third runner's time was 52 seconds, what would the function be? We can't have the same input but have a different output, so this is false. Time can't be a function of distance. C. Speed is a function of number of students racing. False. The speed doesn't get affected by the number of students racing. It doesn't matter if there's 2 students racing or 100 students racing. D. Time is a function of speed. Imagine that the input is speed, meters per second. So let's say that this person ran 50 meters in 11 seconds. The function could be 100 meters divided by 22 seconds, which is equivalent to 50 meters in 11 seconds. Imagine the input is 4/1. The function could be 100 meters divided by 25 seconds, if the time was 25 seconds. 100 over 25 is equivalent to 4/1, or 100 meters in 25 seconds is equivalent to 4 meters in 1 second. This is true. There is one time for each speed found. Problem number 3 from 8th grade, Unit 4, Lesson 15. Diego's history teacher writes a test for the class with 26 questions. The test is worth 123 points and has 2 types of questions: multiple choice worth 3 points each, and essays worth 8 points each. How many essay questions are on the test? Explain or show your reasoning. Multiple choice plus essay equals 26. Since multiple choice questions are worth 3 points each, we can represent multiple choice as 3M, and essay questions are worth 8 points each, so we can represent essay questions as 8E. The whole test is worth 123 points. The 26 questions represents a total of 123 points. So the equation reads 3m plus 8e equals 123. Let's solve for m in this first equation. We can do that by subtracting e from both sides. M equals 26 minus e. So now that we know what m equals, we can substitute 26 minus e where the m is in this second equation. The new equation reads 3 times 26 minus e plus 8e equals 123. Use the distributive property and multiply 3 times 26 and 3 times minus e. We need to collect like terms. Negative 3e plus 8e, that's the same thing as 8e minus 3e, or 5e. Since we're solving for e, we need to subtract 78 from both sides. That leaves us with 5e equals 45. We want just one e, so let's divide both sides by 5. 5e divided by 5 equals 1e, and 45 divided by 5 equals 9. We know that e equals 9. Now we can substitute e with 9, making m equal to 26 minus 9. So m is equal to 17. There are 9 essay questions and 17 multiple choice questions. Problem number 4. These tables correspond to inputs and outputs. Which of these input and output tables could represent a function rule, and which ones could not? Explain or show your reasoning. All of the inputs for table A are different. As long as the inputs are all different, you can have some outputs the same. So, table A represents a function rule. Some of the inputs for table B are the same, yet they have different outputs, and that's not possible. Table B does not represent a function rule. All of the inputs for table C are different. All of the outputs for table C are the same, and this is possible. So table C is representing a function rule. Table D. All of the inputs for table D are the same, but all of the outputs for table D are different, and you cannot have different outputs for the same inputs. So table D is not representing a function rule. 8th grade Unit 5, Lesson 3, Equations for Functions. Problem number 1. Here is an equation that represents a function. 72x plus 12y equals 60. Select all the different equations that describe the same function. A. Let's look at the term on the right side of the equal sign. It's 600. And compared to the original equation, that term used to be 60. So it's actually 10 times bigger than it used to be. Look at the y term. It went from 12y times 10 and became 120y. And now let's look at the x term. It went from 72x to 720x. It was multiplied by 10. So all three terms were multiplied by 10. Another important thing that I noticed is all the terms that were on the left side of the equal sign remained on the left side of the equal sign, and all the terms that were on the right side of the equal sign remained on the right side of the equal sign. This next equation will tell us why that's important. Let's look at this term y to the left of the equal sign. There's one y, but in the original equation, there used to be 12y. 12y divided by 12 equals 1y. Now let's look at the term with the x. It's moved from one side of the equal sign to the other side of the equal sign. So not only did the 72x get 12 times smaller by being divided by 12, but they subtracted it from both sides of the equal sign. So 72x divided by 12 equals 6x. But if we move it to the other side of the equal sign, it's because we subtracted that 6x from both sides. So if we're subtracting 6x on the right-hand side, we'd have negative 6x, and it would be canceled out from the left-hand side. The only term left is 60, and it turned into 5, because 60 divided by 12 equals 5. And 60 is still on the right-hand side of the equal sign, and the 5 is on the right-hand side of the equal sign. So this equation follows the same function as the original equation. C. Let's look at the term on the right side of the equal sign. It went from a 60 to a 10. That means it was divided by 6 or got 6 times smaller. 60 divided by 6 is 10. Now let's go to the other side of the equal sign. We see a 12y. 12y divided by 6 is 2y. And then finally, also on the left-hand side of the equal sign is a 72x. Let's divide that by 6 and we get 12x. The equation for C also shares the same function as the original equation. D. Y equals 5 plus 6x. Let's look at the y term on the left-hand side of the equal sign. It started out as a 12y and then became a 1y. So that's 12 times smaller. So 12y divided by 12 equals 1y. Now let's look at the x term. The x term actually went from the left-hand side of the equation to the right-hand side of the equation. 72x divided by 12 equals 6x. However, if we were to subtract 6 from both sides, it would end up as a negative 6x on the right-hand side of the equal sign. D says it's a positive 6x, but it should be a negative 6x. So D does not follow the same function as the original equation. E. Let's look at the x term in the original equation. It started out as a 72x and then became a 1x. So it was obviously divided by 72. Let's look at the 60 in the original equation. It started as a 60, then was divided by 72 and became 5/6. And 60 over 72 is equivalent to 5 over 6. So there's one term left. That's the term with a y in it. It starts out on the left side of the equal sign and then ends up on the right side of the equal sign. So let's see if 12y divided by 72, then subtracted from both sides of the equal sign, is indeed negative y over 6. Let's find out. We can subtract 12y divided by 72 from both sides. It gets canceled out from the left side, and this is what's left on the right side. Negative 12y divided by 72 is the same as negative 12y over 72. 12 goes into negative 12 evenly, and 12 goes into 72 evenly. So we can divide the top and the bottom by 12. Negative 12y divided by 12 is y, and 72 divided by 12 is 6. So E does follow the same function as the original equation. F. Let's look at the term on the right side of the original equation, 60. 60 becomes a 6. 60 divided by 10 equals 6. So let's see if the other terms are also 10 times smaller. 72x divided by 10 does not equal 7x. And 12y divided by 10 does not equal 2y. So the equation for F does not follow the same function as the original equation. G. 1x equals 5 over 6 plus y over 6. 72x in the original equation divided by 72 equals 1x. Let's divide 60 by 72. 60 over 72 represents 60 divided by 2. 12 goes into 60 evenly, and 12 goes into 72 evenly. 60 divided by 12 is 5, and 72 divided by 12 is 6. 60 divided by 72 is equivalent to 5 over 6. Let's look at the term with a y in it, 12y. It was subtracted from both sides, so it should be a negative on the right-hand side of the equal sign. But when we look at G, it's written as a positive. Equation G does not represent the function of the original equation. Problem number 2 from 8th grade, Unit 4, Lesson 13. A. Graph a system of linear equations with no solutions. This means I need to graph two lines that have the same slope but different y-intercepts. The y-intercept for this line is 3, and the y-intercept for the next line is 6. They have the same slope and different y-intercepts. B. Write an equation for each line you graph. I can start out the equations for both of these lines with y equals. Next, we need to figure out what the slope is. The rise is up 1, and the run is to the right 1. A slope of 1 over 1 is the same as a slope of 1. For both equations, this middle term will be 1 over 1 times m, or 1 times m. Now we need to find the last term for each of these equations. This is where the equations will be different. For the blue line, the y-intercept is 3, so the equation reads y equals 1m plus 3. For the purple line, the y-intercept is 6, so the equation reads y equals 1m plus 6. You can rewrite these equations as y equals m plus 3 and y equals m plus 6. Problem number 3. Brown rice costs $2 per pound and beans cost $1.60 per pound. Lynn has $10 to spend on these items to make a large meal of beans and rice for a potluck dinner. Let B be the number of pounds of beans Lynn buys and R be the number of pounds of rice she buys when she spends all her money on this meal. A. Write an equation relating the two variables. Rice at $2 per pound can be expressed as 2R, and beans at $1.60 per pound can be expressed as 1.6B. So the equation would read 2R plus 1.6B equals 10. B. Rearrange the equation so B is the independent variable. To get the R by itself, we have to divide every term by 2. 2R divided by 2 is 1R. 10 divided by 2 is 5. Now we can divide the independent variable by 2. 1.6b divided by 2 equals 0.8b. Since we need the independent variable on the other side of the equal sign, we have to subtract 0.8b from both sides. Now the equation reads r equals 5 minus 0.8b. C. Rearrange the equation so r is the independent variable. Let's start with the original equation, 2r plus 1.6b equals 10. Now we want r as the independent variable. Let's get the r on the other side of the equal sign by subtracting 2r from both sides. 2r minus 2r cancels each other out. Next, let's get the b by itself so that it's just 1b, and we'll do that by dividing both sides by 1.6. Every term needs to be divided by 1.6. 1.6b divided by 1.6 equals b. 10 divided by 1.6 equals 6.25. And negative 2r divided by 1.6 equals negative 1.25r. That leaves us with the equation b equals 6.25 minus 1.25r. Problem number 4 from 8th grade, Unit 4, Lesson 6. Solve each equation and check your answer. A. Use the distributive property to multiply 4 times 3, that's 12, and 4 times a negative 2x, that's negative 8x. Bring down the 2x and combine like terms. 2x minus 8x is negative 6x. Now you have 12 minus 6x on the left side of the equal sign, and on the right side of the equal sign, use the distributive property to multiply 3 times 2x, that's 6x, and 3 times a positive 2, that's a positive 6. And that's over 6, so we have to divide both those terms by 6. 6x divided by 6 is 1x, or x, and 6 divided by 6 is 1. Combine like terms, and 1 plus 4 is 5. Let's add 6x to both sides. Negative 6x plus 6x cancels each other out, and x plus 6x equals 7x, because that's like 1x plus 6x. To get the 7x by itself, let's subtract 5 from both sides. 5 minus 5 cancels each other out, and 12 minus 5 equals 7. To make the x just 1x, we have to divide both sides by 7. 7x divided by 7 is x, and 7 divided by 7 is 1. X equals 1. To check your answer, substitute a 1 in place of all of the x's. B. 4z plus 5 equals negative 3z minus 8. Add 3z to both sides. Negative 3z plus 3z cancels each other out, and 4z plus 3z equals 7z. Subtract 5 from both sides of the equal sign. 5 minus 5 cancels each other out, and negative 8 plus a negative 5 equals a negative 13. Let's make the z just 1z by dividing both sides by 7. 7z divided by 7 equals 1z, and negative 13 divided by 7 equals negative 13 sevenths. Z equals negative 13 sevenths. You can check your answer by substituting the z with a negative 13 sevenths. C. Let's look at this term on the right. Q minus 1 over 4. That's the same as Q over 4 minus 1 over 4. Since we're subtracting fractions, let's make a common denominator of 8. So for the first term, we need to multiply the numerator and the denominator by 4. So 1/2 becomes 4/8. We need to multiply the numerator and the denominator times 2. So 4 becomes 8 and q becomes 2q. And for this last term on the right, we need to multiply the numerator and denominator by 2. So the 4 becomes an 8 and the 1 becomes a 2. Let's collect the q's just on one side of the equal sign. And we can do this by adding 1/8 q to both sides. Negative 1/8 q plus 1/8 q cancels each other out, and 2q over 8 plus 1q over 8 equals 3q over 8. To get the term with the q in it by itself, we have to add 2/8 to both sides. Negative 2/8 plus 2/8 cancels each other out, and 4/8 plus 2/8 equals 6/8. To make the q just 1q, we have to multiply by the reciprocal of 3/8. So we have to multiply both sides by 8/3. 3/8 q times 8/3 equals 1q, and 8/3 times 6/8 equals 48/24, which is equal to 2. So q equals 2. You can check your answer by substituting the q with the 2. Eighth grade, Unit 5, Lesson 5, More Graphs of Functions. Problem number 1. Match each diagram to the function described. Then label the axes appropriately. Diagram A matches function number 2. The function inputs the edge length e of a cube and outputs the volume v. Edge length e would be the horizontal axis or the x-axis, and volume v would be the vertical axis or the y-axis. This graph shows that as the edge length of a cube, e, increases, the volume of the cube, v, also increases. Diagram B matches function 5. The function inputs the time of day, lowercase t, and predicts the temperature, capital T. The time, lowercase t, is the horizontal axis or the x-axis, and the temperature, capital T, is the vertical axis or the y-axis. This graph shows that as the time of day increases and the sun rises, the temperature increases. But as we all know, as time moves forward later in the day, the sun goes down, causing the temperature to also go down. Diagram C matches function 4. The function inputs the height of a triangle with a base 12 and outputs the area A. The horizontal axis or the x-axis is the height h, and the vertical axis or the y-axis is the area A. This graph shows that as the height of the triangle increases, the area of the triangle also increases at a constant rate. Diagram D matches function G. The function inputs the time of day t and predicts the number of cars washed at a student car wash C. The horizontal axis or the x-axis represents the time of day t, and the vertical axis, which is the y-axis, represents car wash C. This graph shows that once the students finally opened up the car wash, the number of cars washed increased at a constant rate. Diagram E matches function 3. The function inputs the distance traveled d and predicts the amount of fuel left in the tank, F. The horizontal axis, or the x-axis, represents distance, d, and the vertical axis, or the y-axis, represents fuel, F. This graph shows that as the distance traveled increases, the amount of fuel left in the tank decreases. Diagram F matches function 1. The function inputs the age of an oak tree, A, and outputs a prediction of the height of the tree, H. The horizontal axis, or the x-axis, represents age, and the vertical axis, the y-axis, represents height. This graph shows that in the first few years, the height of the tree increased pretty rapidly, and then as the years progressed, the height of the tree increased more slowly. Problem number 2 from 8th grade, Unit 4, Lesson 13. The solution to a system of equations is 6 and -3. Choose two equations that might make up the system. To do this, we can substitute the x value with a 6 and the y value with a -3. Let's start with A. Y equals -3x plus 6. After we substitute these values, it reads -3 equals 3 times 6 plus 6. -3 equals 18 plus 6. -3 does not equal 24, so equation A could not make up the system. Let's try equation B. Let's substitute the x with a 6 and substitute the y with a -3. Now the equation reads -3 equals 12 minus 9. 12 minus 9 equals 3, and -3 does not equal 3, so equation B could not make up the system. Equation C. Let's substitute the x with a 6 and substitute the y with a -3. Now the equation reads -3 equals -30 plus 27, and -30 plus 27 equals -3. -3 does equal -3, so C might make up the system. Let's try D. Let's substitute the x with a 6 and the y with a -3. Now the equation reads -3 equals 12 minus 15. Since 12 minus 15 equals -3, -3 does equal -3, so equation D also might make up the system. Even though the instructions said choose two equations that might make up the system, and we've already found two equations that make up the system, let's go ahead and see if equation E also might make up the system or not. Substitute the x value with a 6 and the y value with a -3. Now the equation reads -3 equals -24 plus 27. -24 plus 27 equals +3. And since -3 does not equal +3, equation E does not make up the system. Problem number 3 from 8th grade, Unit 5, Lesson 3. A car is traveling on a small highway and is either going 55 miles per hour or 35 miles per hour, depending upon the speed limits, until it reaches its destination 200 miles away. Letting x represent the amount of time in hours that the car is going 55 miles per hour, and y being the time in hours that the car is going 35 miles per hour, an equation describing the relationship is 55x plus 35y equals 200. A. If the car spends 2.5 hours going 35 miles per hour on the trip, how long does it spend going 55 miles per hour? We can substitute the y with 2.5, since y represents the amount of time that the car was traveling 35 miles per hour. Now the equation reads 55x plus 35 times 2.5 equals 200. 35 times 2.5 equals 87.5. Let's subtract 87.5 from both sides of the equal sign. Now the equation reads 55x equals 112.5. To find the value for x, we need to divide both sides by 55. 55x divided by 55 equals 1x or x, and 112.5 divided by 55 equals 2.045, which is approximately 2.05. So 1x equals 2.05 hours. Since x represents the amount of time driven at 55 miles per hour, then the car travels 55 miles per hour for 2.05 hours. B. If the car spends 3 hours going 55 miles per hour on the trip, how long does it spend going 35 miles per hour? Let's start with the original equation, 55x plus 35y equals 200. Now we're going to substitute the x with a 3 to represent the 3 hours going 55 miles per hour on the trip. 55 times 3 equals 165. So now the equation reads 165 plus 35y equals 200. Subtract 165 from both sides of the equal sign. Now the equation reads 35y equals 35. Divide both sides by 35. 35y divided by 35 equals 1y or y, and 35 divided by 35 equals 1. Y equals 1, which is equal to 1 hour. So if the car spent 3 hours going 55 miles per hour, the car would have spent 1 hour traveling 35 miles per hour. C. If the car spends no time going 35 miles per hour, how long would the trip take? Explain your reasoning. Again, we can start with the original equation, 55x plus 35y equals 200. We can substitute the y with a 0 because that means that it traveled 0 hours at 35 miles per hour. Now the equation reads 55x equals 200. We can divide both sides of the equal sign by 55. 55x divided by 55 equals 1x or 1. And 200 divided by 55 equals 3.636, which means if the car was never traveling 35 miles per hour and only traveled 55 miles per hour, it would take 3.64 hours to travel 200 miles. Problem number 4. The graph represents an object that is shot upwards from a tower and then falls to the ground. The independent variable is time in seconds, and the dependent variable is the object's height above the ground in meters. A. How tall is the tower from which the object was shot? Look at the graph and look at the vertical axis, the y-axis, the height in meters. The height of the tower must be the y-intercept, which is 10 meters. B. When did the object hit the ground? To find when the object hit the ground, look at the x-axis, the horizontal axis, and you can see the point at 6 seconds after it was shot, it had hit the ground. C. Estimate the greatest height the object reached and the time it took to reach that height. Indicate this situation on the graph. To do this, all we have to do is find the highest point on the graph. Next, look to the y-axis just to the left, and we can estimate the greatest height. To me, it looks like the greatest height is just about at the 93 meter mark. And then if I look straight down below that, along the horizontal x-axis, it looks like it had taken approximately 2.9 seconds to reach its greatest height. 8th grade, Unit 5, Lesson 6, Even More Graphs of Functions. Problem number 1. Match the graph to the following situations. You can use a graph multiple times. For each match, name the possible independent and dependent variables and how you would label the axes. For graph A, the starting point is greater than 0, and graph A shows increasing at a constant rate. Graph B has a starting point also greater than 0, and graph B shows the same amount decreasing. And finally, graph C has a starting point that's greater than 0, and graph C shows an amount decreasing. A. Tyler pours the same amount of milk from a bottle every morning. That will match up with graph B. As you can see, each morning
Tyler is pouring the same amount of milk, and the amount of milk in the bottle is decreasing as the days increase. B. A plant grows the same amount every week. That matches graph A. As you can see, the starting point of the graph is the size of the plant when it was planted, and then each week it grows at a constant rate. C. The day started very warm, but then it got colder. This matches with graph C. As you can see, graph C starts with a very warm temperature. The temperature decreases as the time of day increases. D. A carnival has an entry fee of $5 and tickets for rides cost $1 each. This situation matches graph A. The y-intercept represents the $5 entry fee, and its positive slope represents the money spent on rides. Problem number 2. Jada fills her aquarium with water. The graph shows the height of the water in centimeters in the aquarium as a function of time and minutes. Invent a story of how Jada fills the aquarium that fits the graph. First, she turns on the water and fills the tank for 2 minutes. Jada stops to rest for 1 minute. Then Jada resumes filling the tank for another 2 minutes. Then she drains out some water for 2 minutes. For the next 3 minutes, she doesn't add or remove any water. Problem number 3 from 8th grade, Unit 5, Lesson 4. Recall the formula for area of a circle. The area of a circle is pi times the radius squared. A. Write an equation relating a circle's radius r and the area A. A equals pi r squared. B. Is area a function of the radius? Yes. Is radius a function of the area? Yes. C. Fill in the missing parts of the table. Let's start with the formula A equals pi r squared. We can substitute the r, or the radius, with a 3. Since the table has a 3 for the radius, well, the radius squared would mean 3 squared, and 3 times 3 equals 9. The area would be 9 times pi, or 9 pi. Let's look at the next column in the table. This time they don't give us a radius, but they give us the area, and the area is 16 times pi. We have to ask ourselves, what radius times itself would equal 16, and that would be 4. Since 4 times 4 equals 16, we know that the radius is 4. Let's look at the next column in the table. The radius is 1/2. Since the area equals pi times radius squared, we can substitute the 1/2 for the radius, or substitute the 1/2 for r. Now it reads area equals pi times half times a half. Since half of a half is a fourth, the area equals pi times 1/4, or 1/4 pi. And finally, let's look at the last column in the table, where the area is equal to 100 times pi, or 100 pi. So we have to ask ourselves, what could the radius be if the radius squared, or the radius times the radius, equals 100? That would have to be 10, because 10 times 10 equals 100. When the area of a circle is 100 times pi, then its radius is 10. Problem number 4 from 8th grade, Unit 3, Lesson 11. The points with coordinates 4 and 8, 2 and 10, and 5 and 7 all lie on the line 2x plus 2y equals 24. A. Create a graph, plot the points, and sketch the line. First, let's make a graph, and now we can plot the various points. 4 and 8, 2 and 10, and 5 and 7. Now we can sketch the line by drawing the line through these 3 points. B. What is the slope of the line you graphed? Down 2 and to the right 2. So that's -2 over +2, which is equal to -1. The slope of this line is -1. C. What does this slope tell you about the relationship between lengths and widths of rectangles with perimeter 24? For every unit added to the length, a unit must be removed from the width, and vice versa. 8th grade, Unit 5, Lesson 7, Connecting Representations of Functions. Problem number 1. The equation and the tables represent two different functions. Use the equation b equals 4a minus 5 and the table to answer the questions. This table represents c as a function of a. A. When a is negative 3, is b or c greater? Let's start with the equation b equals 4a minus 5 and substitute a with negative 3. Now the equation reads b equals 4 times negative 3 minus 5. Since 4 times negative 3 is negative 12, the equation reads b equals negative 12 minus 5. And negative 12 minus 5 is negative 17. So in this case, b equals negative 17. The table shows us when a equals negative 3 that c is equal to negative 20. Since negative 17 is greater than negative 20, b is greater than c when the value for a is negative 3. B. When c is 21, what is the value of a? What is the value of b that goes with the value of a? Let's look at the table. In the table, when c is 21, a is 5. In this case, we can substitute the a with a 5. So the original equation reads b equals 4 times 5 minus 5. 4 times 5 is 20, and 20 minus 5 is 15. When c equals 21, a equals 5, and b equals 15. C. When a is 6, is b or c greater? Again, let's start with the original equation, b equals 4a minus 5, and substitute the a with a 6. The equation now reads b equals 4 times 6 minus 5. Since 4 times 6 is 24, the equation reads b equals 24 minus 5. And 24 minus 5 is 19, so in this case, b equals 19. Look at the table. The table doesn't show me the value of c if a is 6. Therefore, I can't compare b and c. D. For what values of a do we know that c is greater than b? Let's look at the table. When a is negative 3, b is negative 17, and negative 20 is not greater than negative 17. Let's look at when a is 0. 4 times 0 is 0. 0 minus 5 is negative 5. B's value would be negative 5, which is less than 7, C's value. So when A is 0, C is greater than B. Let's look at this next one. When A is 2. When A is 2, 4 times 2 is 8. 8 minus 5 is 3. When A is 2, C is worth 3. And B is also worth 3. So in this case, they're equal, and C is not greater than B. Let's look at the next one. When A is 5, 4 times 5 is 20. 20 minus 5 is 15. When A is 5, B is 15, and C equals 21. Therefore, C is greater than B when A is 5. Let's look at the next one. Let's substitute the 10 for A, and we have 4 times 10, which is 40. 40 minus 5 is 35. When A is 10, B is 35, and C is 19. So C is not greater than B when A is 10. Let's look at the last one. Let's substitute a 12 for A. 4 times 12 is 48. 48 minus 5 is 43. When A is 12, B is 43, and C is 45. And 45 is greater than 43, so C is greater than B when A equals 12. 0, 5, and 12 are the values of A where C is greater than B. Problem number 2 from 8th grade, Unit 5, Lesson 2. Match each function rule with the value that could not be a possible input for that function. Function rule A, 3 divided by the input. 3 divided by 0 is undefined, and that could not be a possible input for that function. So 4, which is the value of 0, matches with A. B, add 4 to the input, then divide this value into 3. B kind of reminds me of A, when we had 3 divided by the input, and the input was 0. So that was 0 divided into 3. So if we were to take -4 and add 4, then we get 0. 3 divided by 0 is undefined, and therefore it could not be a possible input for that function. So 3, which is -4, is a match for function rule B. C, subtract 3 from the input, then divide this value into 1. Take a look at option number 1. Option number 1 has an input of 3, and 3 minus 3 is 0. 1 divided by 0 is undefined. So function rule C matches option number 1 with the input of 3. Problem number 3. Elena and Lynn are training for a race. Elena runs her mile at a constant speed of 7.5 miles per hour. Lynn's times are recorded every minute. A, who finished their mile first? 60 minutes divided by 7.5 miles equals 8 minutes. It takes Elena 8 minutes to complete 1 mile. Let's look at Lynn's chart. It takes Lynn 9 minutes to run 1 mile. It takes Elena 8 minutes to complete 1 mile, and it takes Lynn 9 minutes to complete 1 mile. Elena finishes her mile in less time. B, this is a graph of Lynn's progress. Draw a graph to represent Elena's mile on the same axes. I've decided to create a table on the left-hand side. We know that it takes Elena 8 minutes to run 1 mile. 8 divided by 8 equals 1 minute, and 1 mile divided by 8 equals 1/8 of a mile, or 0.125 miles. 1 minute times 2 equals 2 minutes. 1/8 of a mile times 2 equals 1/4 of a mile, or 0.125 times 2 equals 0.25 miles. As I continue to fill in this table, I'm adding 1 minute to the left-hand column, and I'm adding 1/8 of a mile to the right-hand column, or I'm adding 0.125 miles to the right-hand column. The left-hand column of this table corresponds with the x-axis of the graph, time in minutes. The right-hand column of the table corresponds with the y-axis of the graph, distance in miles. You can continue to complete this table on your own if you like. I went ahead and represented Elena's mile on this graph with red points. C, for these models, is distance a function of time? Is time a function of distance? Explain how you know. Given a time for each model, the distance for that time can be found, and given a distance for each model, the time for that distance can be found. Problem number 4 from 8th grade, Unit 4, Lesson 4. Find a value of x that makes the equation true. Explain your reasoning and check that your answer is correct. We can start by using the distributive property and multiplying the negative sign by -2x, making it a positive 2x, and by multiplying the negative sign times the positive 1, making it a -1. Now the equation reads 2x minus 1 equals 9 minus 14x. Let's add 14x to both sides. Now the equation reads 16x minus 1 equals 9. Let's add 1 to both sides. Now the equation reads 16x equals 10. Divide both sides by 16, and you have 1x, or x, equals 10 over 16. Which is equivalent to 0.625. X equals 625 thousandths. Next, we have to check to see if our answer is correct. And we can do that by substituting every x with 625 thousandths. 2 times 625 thousandths minus 1 equals 9 minus 14 times 625 thousandths. Now the equation reads 1 and 25 hundredths minus 1 equals 9 minus 8 and 75 hundredths, which is equal to 25 hundredths equals 25 hundredths. Since that's true, 25 hundredths does equal 25 hundredths, we know the answer is correct.
Eighth grade, Unit 5, Lesson 8, Linear Functions. Problem number 1. Two cars drive on the same highway in the same direction. The graphs show the distance d of each one as a function of time, t. Which car drives faster? Explain how you know. The y-axis, or the vertical axis, is labeled d. It represents distance. The x-axis, or horizontal axis, is labeled t. That represents time. Which car drives faster? Which line reaches the furthest distance in the shortest amount of time? The line for car B reaches the furthest distance in the shortest amount of time. So car B drives faster. Problem number 2. Two car services offer to pick you up and take you to your destination. Service A charges 40 cents to pick you up and 30 cents for each mile of your trip. Service B charges $1.10 to pick you up and charges C cents for each mile of your trip. A. Match the services to the lines L and M. The y-intercept for line L is just a little bit greater than 1. That represents the service charge, which is $1.10, a little bit more than $1. So line L would match up with service B. And the y-intercept for line M is less than half of 1. So that would match up with the 40-cent service charge for service A. Problem number 3. Kieran and Claire like to race each other home from school. They run at the same speed, but Kieran's house is slightly closer to school than Claire's house. On a graph, their distance from their homes in meters is a function of the time from when they begin the race in seconds. A. As you read the graphs left to right, would the lines go up or down? This example of their graph shows that the distance from home at the start of the race is greatest, and the distance from home at the end of the race is smallest, so their lines would go down from left to right. B. What is different about the lines representing Kieran's run and Claire's run? Their lines have different y and x intercepts. C. What is the same about the lines representing Kieran's run and Claire's run? These lines have the same slope. Problem number 4 from 8th grade, Unit 3, Lesson 11. Write an equation for each line. We can use this slope-intercept form template. This space represents the slope, and this space represents the y-intercept. Let's start with the green line. The green line has 0 slope, so we insert a 0 in this space. And the y-intercept is at -2, so we insert a -2 in this space. So now the equation reads y equals 0 times x plus -2. And that's the same thing as y equals -2. What that means is, no matter where you are on this green line, the y value is -2. Now let's look at the yellow line. The yellow line has a slope that goes down 3, so that's a -3, and to the right 1. So it's a -3 slope. And the y-intercept is located at +5. Now the equation reads y equals -3x plus 5. Now let's take a look at the red line. The red line has a slope of up 2, so that's a +2, and to the right 1, that's a +1. So that's a slope of 2. And the y-intercept of the red line is located at 5. Now the equation reads y equals 2x plus 5. Next, let's look at the black line. The black line has the same slope as the red line, and that's 2. And it has a y-intercept of -6. So the equation reads y equals 2x plus -6, which is the same as y equals 2x minus 6. And finally, let's look at the vertical blue line. The vertical blue line has no slope. It's also called an undefined slope. And you'll notice that it doesn't have a y-intercept either because it's a vertical line. The x-intercept is 5. The x value will always be 5 no matter where you are on this vertical line. The equation reads x equals 5. 8th grade, Unit 5, Lesson 9, Linear Models. Problem number 1. On the first day after the new moon, 2% of the moon's surface is illuminated. On the second day, 6% is illuminated. A. Based on this information, predict the day on which the moon's surface is 50% illuminated and 100% illuminated. I'll make a chart and label the first day 2% illuminated. And like they said, the second day was 6% illuminated. So I added 4. So each day we can add 4 until finally we reach 50%. On day 13, we reach 50%. Let's keep going. Right between day 25 and 26, we reach 100%. So on day 13, the illumination will reach 50%. And right about day 26, the illumination will reach 100%. B. The moon's surface is 100% illuminated on day 14. Does this agree with the prediction you made? No, it doesn't agree. The prediction I made, it was 100% illuminated around day 26. C. Is the percentage illumination of the moon's surface a linear function of the day? I put the points on a graph representing 1 day with 2% illumination, 2 days with 6% illumination, and 14 days with 100% illumination. And that would not form a straight line, which means it's not a linear function. Problem number 2. In science class, Jada uses a graduated cylinder with water in it to measure the volume of some marbles. After dropping in 4 marbles, so they are all underwater, the water in the cylinder is at a height of 10 milliliters. After dropping in 6 marbles, so they are all underwater, the water in the cylinder is at a height of 11 milliliters. A. What is the volume of 1 marble? 2 marbles added 1 milliliter to the height of the water. That means that adding 1 marble adds 0.5 milliliters to the height of the water. So the volume for 1 marble is 0.5 milliliters. B. How much water was in the cylinder before any marbles were dropped in? The volume of each marble is 0.5 milliliters. 0.5 milliliters times 6 marbles equals 3 milliliters. 11 milliliters minus those 3 milliliters equals the 8 milliliters that was originally in the graduated cylinder. C. What should be the height of the water after 13 marbles are dropped in? 5 milliliters times 13 marbles equals 6.5 milliliters, and add that to the original 8 milliliters that were in the graduated cylinder, and you get a total of 14.5 milliliters. After adding 13 marbles, the height of the water should be 14.5 milliliters. D. Is the volume of the water a linear relationship with the number of marbles dropped in the graduated cylinder? If so, what does the slope of the line mean? If not, explain your reasoning. Yes, it's linear, and the slope of the line means the volume per marble. Each time you drop 1 marble in the cylinder, the water level rises 0.5 milliliters, and the number of marbles increase by 1. Problem number 3, from 8th grade, Unit 4, Lesson 5. Solve each of these equations. Explain or show your reasoning. We can divide both sides of the equal sign by 2. Subtract 2 from both sides. Subtract 1x from both sides. Divide both sides by 2. 1x equals 6, or x equals 6. Add 3y to both sides of the equal sign. Subtract 13 from both sides of the equal sign. Divide both sides of the equal sign by 8. Y equals -7. We can use the distributive property 4 times 2a plus 4 times 2 and 8 times 2 minus 8 times 3a. Subtract 8 from both sides of the equal sign. Add 24a to both sides of the equal sign. Divide both sides by 32. 8 over 32 is equivalent to 1/4, so a equals 1/4. Problem number 4. For a certain city, the high temperatures in degrees Celsius are plotted against the number of days after the new year. Based on this information, is the high temperature in this city a linear function of the number of days after the new year? The points are plotted on this graph. The rise is 4 and the run is 2. From this point to the point on the top, the rise is 14 and the run is 7. 7 over 14 is a slope of 2, just like 4 over 2 is a slope of 2. And if you were to draw a line straight through these points, you would have a straight line. The straight line proves that it is a linear function. However, to use a linear model for this situation doesn't really make sense because after a couple months, the temperatures would be so hot that you couldn't survive. Problem number 5. From 8th grade, Unit 4, Lesson 15. The school designed their vegetable garden to have a perimeter of 32 feet, with the length measuring 2 feet more than twice the width. A. Using L to represent the length of the garden and W to represent its width, write and solve a system of equations that describes this situation. Here's a garden box with the length and the width, and you notice that there's 2 lengths and 2 widths. The perimeter is equal to length plus width plus width. And that's the same thing as 2L plus 2W. And adding them all together will give you the perimeter, which is 32 feet. The length of this particular garden box measures 2 feet more than twice the width. So we can write that as L equals 2 plus 2W. So we know that the length equals 2 plus 2W. That means that we can substitute this L with 2 plus 2W. So we can rewrite this equation as 2 times 2 plus 2W plus 2W equals 32. Next, use the distributive property. 2 times 2 is 4 plus 2 times 2W. Next, we can collect like terms. 4W plus 2W equals 6W. Subtract 4 from both sides of the equal sign. Divide both sides by 6. Now we know that 1W equals 28 over 6, which is equivalent to 4 and 4/6 and can be simplified to 4 and 2/3. W equals 4 and 2/3. Now we can substitute the W with 4 and 2/3, or 28 over 6. Now we can rewrite the equation as L equals 2 plus 2 times 28 over 6, which means L equals 2 plus 2 times 28 over 6. And 2 times 28 over 6 is 28/3. So L equals 2 plus 28/3. 2 is equivalent to 6/3. So we can add 6/3 to 28/3. That gives us 34/3. So we know that L equals 34/3, which can be written as 11 1/3. Now we know that the width of the garden box is 4 2/3 feet and the length of the garden box is 11 1/3 feet.
Eighth grade, Unit 5, Lesson 10. piecewise linear functions. Problem number 1. The graph shows the distance of a car from home as a function of time. Describe what a person watching the car may be seeing. According to this graph, it looks like the car is driving to a location, perhaps a store, then stops for a while, and then drives back home. Problem number 2 from 8th grade, Unit 5, Lesson 7. The equation and the graph represent two functions. Use the equation y equals 4 and the graph to answer the questions. A. When x is 4, is the output of the equation or the graph greater? Looking at the graph, when x is 4, y is 3, or when the input is 4, the output is 3. For the equation, when x is 4, y is 4, or when the input is 4, the output is 4. When the value of x is 4, the value of the output is greater for the equation than it is for the graph. B. What value for x produces the same output in both the graph and the equation? In the original graph, when x is 6, y is 4, and the blue-colored line or the blue-colored graph represents the equation y equals 4. When x is 6, y is also equal to 4. When the value for x is 6, both the graph and the equation have the same output. Problem number 3. This graph shows a trip on a bike trail. The trail has markers every 0.5 kilometers or half a kilometer, showing the distance from the beginning of the trail. A. When was the bike rider going the fastest? The horizontal axis or the x-axis is time in hours, and the vertical axis or the y-axis is distance from beginning in kilometers. Between 2.4 and 2.6 hours, the bike traveled 5 kilometers. So the bike rider was going the fastest between 2.4 and 2.6 hours. B. When was the bike rider going the slowest? Between 0.8 and 1.4, the bike rider was actually stopped, and that's not considered traveling. But between 1.4 and 2.2, the bike rider only traveled 2 kilometers. So the bike rider traveled the slowest between 1.4 and 2.2 hours. C. During what times was the rider going away from the beginning of the trail? Between 0 and 2.2 hours, the rider was traveling away from the beginning of the trail. D. During what times was the rider going back towards the beginning of the trail? Between 2.4 and 3 hours, the rider was going back towards the beginning of the trail. E. During what times did the rider stop? The rider stopped between 0.8 and 1.4 hours, and the rider stopped again between 2.2 and 2.4 hours. Problem number 4 from 8th grade, Unit 4, Lesson 9. The expression negative 25t plus 1,250 represents the volume of liquid of a container after t seconds. The expression 50t plus 250 represents the volume of liquid of another container after t seconds. What does the equation negative 25t plus 1,250 equals 50t plus 250 mean in this situation? The system of equation can be solved for t to find the time that both containers have the same volume. 8th grade, Unit 5, Lesson 11, Filling Containers. Problem number 1. Cylinder A, B, and C have the same radius but different heights. Put the cylinders in order of their volume from least to greatest. Cylinder B has the shortest height. It's going to have the least volume. Cylinder C has the next shortest height. So cylinder C would have the second most volume of the 3 cylinders. And finally, cylinder A. It's the tallest of the 3 cylinders, therefore it's going to have the greatest volume of the 3 cylinders. The volume of the cylinders from least to greatest is B, C, A. Problem number 2. 2 cylinders, A and B, each started with different amounts of water. The graph shows how the height of the water changed as the volume of water increased in each cylinder. Match the graphs of A and B for cylinders P and Q. Explain your reasoning. First, you can tell that they started with different amounts of water by looking at the vertical axis, the y-axis, and you can see where the lines start. That's the y-intercept. Both graphs start at different points of the y-axis. Graph A shows that the height in centimeters increases at a faster rate than graph B. The cylinders are the same height, but cylinder Q has a smaller radius, so it will fill faster. The height of graph A increases faster than graph B, so cylinder Q matches with graph A and cylinder P matches with graph B. Problem number 3. Which of the following graphs could represent the volume of water in a cylinder as a function of its height? Explain your reasoning. As the height of the cylinder increases, the volume of water increases at the same rate. So I would select the graph on the left because as the height increases, the volume of water also increases at the same rate. Problem number 4 from 8th grade, Unit 5, Lesson 3. Together, the areas of the rectangle sum to 30 square centimeters. A. Write an equation showing the relationship between x and y. For the rectangle on the left, we have the area equals length times width, which is also equivalent to width times length. And since the length is x, and the width is 3, the area equals 3x, or 3 times x. And for the rectangle on the right, again we have area equals length times width, and in this case the length is y and the width is 2. So the area equals 2y, or 2 times y. To write an equation showing the relationship between x and y, we can take the 3x from the rectangle on the left and the 2y from the rectangle on the right and write the equation as follows. 3x plus 2y equals 30. Now we know it equals 30 because the information at the top of this problem says the area of the sum of the two rectangles is 30 square centimeters. B. Fill in the table with the missing values. When x equals 3, this means that we can substitute the x with the 3. So instead of 3 times x, we have 3 times 3 plus 2y equals 30. And 3 times 3 is 9. So now the equation reads 9 plus 2y equals 30. Subtract 9 from both sides of the equal sign, and you're left with 2y equals 21. Since we're solving for y, we need to divide both sides by 2. 2y divided by 2 equals 1y, or y, and 21 divided by 2 equals 10.5. So when the value for x is 3, the value for y is 10.5. Next, they give us the value for y. So when the value for y is 5, we can substitute the y with a 5. Now the equation reads 3x plus 2 times 5 equals 30. Since 2 times 5 is 10, the equation reads 3x plus 10 equals 30. Let's subtract 10 from both sides of the equal sign, and we're left with 3x equals 20. Since we're solving for x, we need to divide both sides of the equal sign by 3. 3x divided by 3 equals 1x, or x, and 20 divided by 3 equals 6.6 repeating, or 6 2/3. So when the value for y is 5, the value for x is 6 2/3. The next one that they give us is the value for x, which is 8. So when the value for x is 8, we can substitute the x with an 8. So now the equation reads 3 times 8 plus 2y equals 30. 3 times 8 is 24, so the equation reads 24 plus 2y equals 30. Let's subtract 24 from both sides of the equal sign, and we're left with 2y equals 6. Since we're solving for y, we'll have to divide both sides by 2. 2y divided by 2 equals 1y or y, and 6 divided by 2 equals 3. When the value for x is 8, the value for y is 3. Next, they give us 10 as the value for y. In this case, we need to substitute the y with 10. So now the equation reads 3x plus 2 times 10 equals 30. Since 2 times 10 is 20, the equation reads 3x plus 20 equals 30. We'll have to subtract 20 from both sides of the equal sign, and we're left with 3x equals 10. Since we're solving for x, we'll have to divide both sides by 3. 3x divided by 3 equals 1x or x, and 10 divided by 3 equals 10/3 or 3 1/3, which is also 3.3 repeating. So when the value for y is 10, the value for x is 3 1/3. Finally, the last value they give us for x is 12, so we'll substitute a 12 for the x. That becomes 3 times 12 plus 2y equals 30. 3 times 12 is 36, so now we have 36 plus 2y equals 30. Next, we need to subtract 36 from both sides of the equal sign. That gives us 2y equals -6. Divide both sides by 2 to get the y by itself, and you have y equals -3. And remember, y equals a side length. So this is not possible because a side length cannot be a negative. I'd like to give a shout out to Froyan Lopez for helping me out with this last problem. I appreciate that. Thank you. 8th grade, Unit 5, Lesson 12. How much will fit? Problem number 1. A. Sketch a cube and label its side length as 4 centimeters. This will be cube A. It's a cube. It's going to have a top, a bottom, a front, a back, a right side, and a left side, and the side lengths will all be 4 centimeters. And label it cube A. B. Sketch a cube with sides that are twice as long as cube A and label its side length. This will be cube B. The side lengths for this cube need to be twice as long as the side lengths for cube A. Since cube A has side lengths that are 4 centimeters long, this cube needs side lengths that are 8 centimeters long. Label the side lengths 8 centimeters and label the cube cube B. C. Find the volumes of cube A and cube B. To find the volume, we have to multiply 3 side lengths. The volume equals lengths times width times height. So for the smaller cube, the volume would be 4 times 4 times 4. The volume for the smaller cube is 64 centimeters cubed, or 64 cubic centimeters. And we'll do the same thing for cube B, the larger cube. The length times the width times the height. 8 times 8 times 8. The volume for the larger cube is 512 cubic centimeters, or 512 centimeters cubed. Problem number 2. Several glass aquariums of various sizes are for sale at a pet shop. They are all shaped like rectangular prisms. A 15-gallon tank is 24 inches long, 12 inches wide, and 12 inches tall. Match the dimensions of the other tanks with the volume of water they can each hold. I could just find the volume of each of these tanks and then see how many times larger or how many times smaller they are compared to the volume of the aquarium in the word problem. But I've decided to look up to see how many cubic inches are in 1 U.S. liquid gallon. And there's 231 cubic inches in a U.S. gallon. What I'll do is I'll find the volume for each of these aquariums, and then I'll see how many times 231 goes into the volume. Here's the first one. 36 times 18 times 12. That's a volume of 7,776 cubic inches. So I'm going to see how many times 231 goes into that. 7,776 divided by 231. That's about 33 gallons if it were filled to the very top. So I would select aquarium number 4, 30 gallons. B. Tank number 2, 16 inches long, 8 inches wide, and 10 inches tall. That's 16 times 8 times 10. The volume for this tank is 1,280 inches cubed. 1,280 divided by 231 is a little over 5.5 gallons. So I would select number 1, the 5 gallons. C. Tank 3, 30 inches long, 12 inches wide, and 12 inches tall. That would be 30 times 12 times 12. That's 4,320 inches cubed. 4,320 divided by 231 is a little bit more than 18.7. So I would select 3, 20 gallons. D. Tank 4, 20 inches long, 10 inches wide, and 12 inches tall. That's 20 times 10 times 12, which equals 2,400 inches cubed. 2,400 divided by 231 equals almost 10.4 gallons. For tank 4, I would go with number 2, 10 gallons. Problem number 3. 2 paper drink cups are shaped like cones. The small cone can hold 6 ounces of water. The large cone is 4/3 the height and 4/3 the diameter of the small cone. Which of these could be the amount of water the large cone holds? We know that the small cone can hold 6 ounces of water. Both the height and the diameter of the large cone is 4/3 or 1 1/3 the height and diameter of the small cone. Here's a look at the small cone and the large cone. The diameter for both of these cones is unknown. We don't know the diameter, but we do know that the diameter of the larger cone is 4/3 or 1 1/3 that of the smaller cone. We also know that the height of the larger cone is also 4/3 or 1 1/3 larger than the height of the smaller cone. Looking back at the question, it asks which of these could be the amount of water the large cone holds. Since the large cone is larger than the smaller cone, and the smaller cone holds 6 ounces of water, there's only one choice here that could be true, and that would be 14 ounces. It couldn't be choices A or D because those are measured in centimeters. Centimeters is one-dimensional, like a length. It couldn't be choice C either because 4.5 ounces is less than 6 ounces. The larger cone would hold more than 6 ounces, so the only possible choice would be B, 14 ounces. Problem number 4 from 8th grade, Unit 5, Lesson 7. The graph represents the volume of a cylinder with a height equal to its radius. A. When the diameter is 2, what is the radius of the cylinder? Radius is half the length of the diameter, so if the diameter is 2, the radius is 1. B. Express the volume of a cube of side length S as an equation. Since the volume equals length times width times height, we can write the equation volume equals S times S times S. Essentially, the volume equals S cubed, or S to the power of 3. C. Make a table for volume of the cube at S equals 0, S equals 1, S equals 2, and S equals 3. S equals 0 means side length equals 0. So with side length 0, the equation would be 0 times 0 times 0 with a volume of 0. With side length 1, the equation would read 1 times 1 times 1, and the volume is 1. With side length 2, the equation would read 2 times 2 times 2, and the volume would be 8. With side length 3, the equation would read 3 times 3 times 3, and the volume is 27. D. Which volume is greater, the volume of a cube when S equals 3, or the volume of a cylinder when its diameter is 3? The volume of a cube when the side length is 3 is 27, or 3 times 3 times 3. Take a look at the horizontal axis of the graph. That's the diameter. When the diameter of the cylinder is 3, the volume of the cylinder is between 10 and 11. When the diameter of a cylinder is 3, the volume is 10.6. Since 27 is greater than 10.6, the volume of the cube is greater. Problem number 5, from 8th grade, Unit 3, Lesson 10. Select all the points that are on a line with slope 2 that also contains the point 2 and negative 1. Let's use the difference of the y values divided by the difference of the x values, or y minus y over x minus x. The y value in the original set of points is negative 1, and the y value for a is 1. So negative 1 minus 1 over the x value 2 minus the x value 3. Negative 1 minus negative 1 is negative 2, and 2 minus 3 is negative 1. Negative 2 divided by negative 1 equals 2. So this has a slope of 2. That means that both these points would be on the same line, and that line would have a slope of 2. B. X value 1, y value 1. Let's use the same strategy. The y value of the original minus the y value of b. Negative 1 minus 1 over the x value of the original minus the x value of b. 2 minus 1. Negative 1 minus negative 1 equals negative 2, and 2 minus 1 equals 1. Negative 2 divided by 1 equals negative 2, and that is not a slope of 2, it's a slope of negative 2. C. 1 and negative 3. So we'll do it the same way we did before. The original y value, negative 1, minus the y value of c, which is negative 3. Negative 1 minus a negative 3. That's the same thing as negative 1 plus 3. And negative 1 plus 3 equals 2. Over the x value for the original, which is 2, minus the x value for c, which is 1. 2 minus 1 is 1. Now we have 2 divided by 1 equals 2. That means that both these points would be on the same line, and that line would have a slope of 2. D. 4 and 0. We can set that up as negative 1 minus 0 over 2 minus 4. Negative 1 minus 0 equals negative 1, and 2 minus 4 equals negative 2. That's equivalent to 1/2, which is not a slope of 2. That's a slope of 1/2. E. 6 and 7. Let's set it up the same way. Negative 1 minus 7 over 2 minus 6. Negative 1 minus 7 is negative 8, and 2 minus 6 is negative 4. A negative divided by a negative is a positive, and 8 divided by 4 is 2. This has a slope of 2. That means that both these points would be on the same line, and that line would have a slope of 2. Problem number 6 from 8th grade, Unit 4, Lesson 14. Solve. We can rewrite this as a system of equations where x plus 4 equals negative 2x minus 20. Add 2x to both sides of the equal sign. That leaves us with 1x plus 2x on the left for a total of 3x, and on the right side of the equal sign, the x's are canceled out. Now the equation reads 3x plus 4 equals negative 20. Let's subtract 4 from both sides of the equal sign. 4 minus 4 cancels each other out, and negative 20 minus 4 equals negative 24. Now the equation reads 3x equals negative 24. Let's divide both sides of the equal sign by 3. 3x divided by 3 equals 1x, or x, and negative 24 divided by 3 equals negative 8. 1x, or x, equals negative 8. Now that we know the value for x is negative 8, we can substitute the x with the negative 8. So the equation y equals x plus 4 can be rewritten as y equals negative 8 plus 4. Since negative 8 plus 4 is negative 4, we know that y equals negative 4. Now we know the values for both x and y. X equals negative 8 and y equals negative 4. 8th grade, Unit 5, Lesson 13, the volume of a cylinder. Number 1. Match each set of information about a circle with the area of that circle. A. Circle A has a radius of 4 units. The area of a circle is pi times r squared, and in this case, r is 4, so 4 squared is 16. So the area of this circle is 16 times pi. This matches with number 4. 16 times pi square units. B. Circle B has a radius of 10 units, so the area for circle B is pi times 10 squared, or pi times 100. Since pi is approximately 3.14 and we multiply 3.14 by 100, the area of circle B matches with 2, approximately 314 square units. C. Circle C has a diameter of 16 units. That means the radius is 8, since the radius is half the diameter and half of 16 is 8. The area of circle C is pi times 8 squared, or pi times 64. Circle C matches with number 3, 64 times pi square units. D. Circle D has a circumference of 4 times pi units. So this information tells us that the circumference equals 4 times pi. That means that the radius must be 2, because 2 times 2 equals 4. So both the circumference is 4 times pi and the area is 4 times pi square units. Circle D matches with 1, 4 times pi square units. Problem number 2. A. Sketch a cylinder. B. Label its radius 3 and its height 10. C. Shade in one of its bases. Problem number 3. At a farm, animals are fed bales of hay and buckets of grain. Each bale of hay is in the shape of a rectangular prism. The base has side lengths 2 feet and 3 feet, and the height is 5 feet. Each bucket of grain is a cylinder with a diameter of 3 feet. The height of the bucket is 5 feet, the same as the height of the bale. A. Which is larger in area, the rectangle base of the bale or the circular base of the bucket? Explain how you know. This diagram represents a bale of hay with a length of 2 feet, a width of 3 feet, and a height of 5 feet. And this diagram represents the bucket with a diameter of 3 feet and a height of 5 feet. The rectangular base of the bale of hay has an area of 2 feet times 3 feet, so that would be 6 feet squared. The circular base of the pail would have an area of pi times r squared. Its diameter is 3 feet, so the radius is going to be half of 3 feet, which is 1.5. So the area would be 3.14 times 1.5 squared, or 3.14 times 2.25. The area of the circular base of the cylinder is approximately 7 feet squared. The circular base of the bucket has a larger area than the rectangular base of the bale of hay. B. Which is larger in volume, the bale or the bucket? Explain how you know. To find the volume of the bale of hay, we need to multiply the length times the width times the height. So the volume equals 2 times 3 times 5. 2 times 3 is 6, 6 times 5 is 30. The volume of the bale of hay is 30 feet cubed. To find the volume of the bucket, we need to multiply pi times r squared times height. 3.14 times r squared times height. Since the diameter is 3, the radius is going to be 1.5. So 3.14 times 1.5 squared times 5. The volume of the bucket is approximately 35 feet cubed. The bucket has the larger volume. Problem number 4. 3 cylinders have a height of 8 centimeters. Cylinder 1 has a radius of 1 centimeter. Cylinder 2 has a radius of 2 centimeters. And cylinder 3 has a radius of 3 centimeters. Find the volume of each cylinder. The formula for finding the volume of a cylinder is pi times r squared times height. Cylinder number 1 has a radius of 1 centimeter, so to find the volume we'll multiply 3.14 times 1 squared times 8 centimeters. Cylinder number 1 has a volume of approximately 25.12 centimeters cubed. Cylinder number 2 has a radius of 2 centimeters, so we'll multiply 3.14 times 2 squared times 8. The volume for cylinder 2 is approximately 100.48 centimeters cubed. Cylinder 3 has a radius of 3 centimeters. We'll multiply 3.14 times 3 squared times 8. Cylinder number 3 has a volume of approximately 226 8/100 centimeters cubed. Problem number 5 from 8th grade, Unit 5, Lesson 12. A 1-quart container of tomato soup is shaped like a rectangular prism. A soup bowl shaped like a hemisphere can hold 8 ounces of liquid. How many bowls will the soup container fill? Recall that 1 quart is equivalent to 32 fluid ounces. Each bowl can hold 8 ounces of liquid, and the soup container can hold 32 fluid ounces. So 32 divided by 8 equals 4. The soup container can fill 4 bowls of soup. Problem number 6 from 8th grade, Unit 5, Lesson 8. 2 students join a puzzle solving club and get faster at finishing the puzzles as they get more practice. Student A improves their times faster than student B. A. Match the students to the lines L and M. The horizontal axis, or the x-axis, represents the number of days of practice, and the vertical axis, or the y-axis, represents minutes to complete a puzzle. Here you can see that line L starts at 6 minutes. On the first day, it took 6 minutes to complete a puzzle. As the days progressed, eventually, it's taken them less than 3 minutes to complete a puzzle. Line M starts at 5 minutes and ends at 4 minutes. Student A is represented by line L, and student B is represented by line M. B. Which student was faster at puzzle solving before practice? Student B was faster before practice, but student A became faster after practice. 8th grade, Unit 5, Lesson 14, Finding Cylinder Dimensions. Problem number 1. Complete the table with all the missing information about 3 different cylinders. Let's look at the base of the cylinder first. They ask about the diameter of the base and the area of the base. Since it's a cylinder, it has a circle as the base. So to find the area of a circle, we need to multiply pi times r squared. When the diameter is 4, the radius is 2. We'll use 3.14 to represent pi. So the area will be 3.14 times 2 squared. 2 squared is the same as 2 times 2, so the area will be 3.14 times 2 times 2, or 12 and 56/100 units squared. Next, we need to find the volume of this cylinder. To find the volume, we need to multiply pi times r squared times the height. The volume is 12 and 56/100 times 10, since the height is 10. The volume is 125 and 6/10 units cubed. The diameter of the base of this next cylinder is 6 units. If the diameter is 6, the radius is 3, so 3.14 times 3 squared, or 3.14 times 9. The area of this base is 28 and 26/100 units squared. They've given us the volume. Now we have to figure out what the height is. The formula for finding the volume of a cylinder is pi times r squared times height. So we need to figure out what height times r squared equals 63. 63 divided by r squared should give us the height. The radius is 3, so r squared is 3 times 3, or 9. 63 divided by 9 gives us the height. And 63 divided by 9 is 7, so the height of this cylinder must be 7 units tall. Problem number 2. A cylinder has volume 45 times pi and radius 3. What is its height? We can use the volume of a cylinder and the information they gave us to help figure out the height. Volume equals pi times r squared times the height. It says that the volume is 45 times pi. The radius squared times the height equals 45. The radius is 3, so 3 squared, or 3 times 3, is 9. What number times 9 equals 45? 5 times 9 equals 45. That means that the height of this cylinder is 5 units. Problem number 3. 3 cylinders have a volume of 2,826 centimeters cubed. Cylinder A has a height of 900 centimeters. Cylinder B has a height of 225 centimeters. Cylinder C has a height of 100 centimeters. Find the radius of each cylinder. Use 3.14 as an approximation for pi. Each of these 3 cylinders have the same volume, but the radius of their base are different and their height are different. As the height increases, the radius is going to decrease. As their height decreases, their radius is going to increase. The formula for finding the volume of a cylinder is pi times r squared times height. The height of the first cylinder is 900 centimeters. The height of the second cylinder is 225 centimeters. And the height of the third cylinder is 100 centimeters. We can figure out the radius by getting r squared alone or by itself. To do this, we need to divide both sides of the equation by pi times the height. Now the first equation reads 1 equals r squared. The radius for the first cylinder is 1, since 1 times 1 equals 1. Now the equation for the second cylinder reads 4 equals r squared. The radius for the second cylinder is 2, since 2 times 2 equals 4. The equation for the third cylinder now reads 9 equals r squared. And the radius for the third cylinder is 3, since 3 times 3 equals 9. Problem number 4 from 8th grade, Unit 5, Lesson 13. A gas company's delivery truck has a cylindrical tank that is 14 feet in diameter and 40 feet long. A. Sketch the tank and mark the radius and the height. B. How much gas can fit in the tank? To find out how much gas fits in the tank, we need to find the volume of the cylinder, or the volume of the tank. And we can do this by multiplying pi times 7 squared times 40. Using 3.14 to represent pi, the volume of the tank is 6,154 and 4/10 cubic feet. Problem number 5 from 8th grade Unit 5, Lesson 5. Here is a graph that shows the water height of the ocean between September 22nd and September 24th, 2016 in Bodega Bay, California. A. Estimate the water height at 12 p.m. on September 22nd. First, locate September 22nd along the horizontal axis or the x-axis, and along the same axis locate 12 p.m. Slide up to the graph and put a point on the line. I estimate that the water height in feet is approximately 3.5 feet or 3.5 feet. B. How many times was the water height 5 feet? Find 2 times when this happens. First, find 5 feet along the vertical axis or the y-axis, and you can see where the line of the graph actually passes through 5 feet 4 different times. I plotted those 4 points in blue. Approximately 2 p.m. and 6 p.m. on September 22nd, the water level passed 5 feet, and approximately 3 p.m. and 7 p.m. on September 23rd, where the water level passed 5 feet. C. What was the lowest point the water got during this time period? When does this occur? The lowest point the water reached looks like it was less than half, maybe about 1/4 of a foot. The lowest point looks like it occurred just before September 23rd at 12 a.m., which would be 12 midnight. So it probably occurred the day before, which would be September 22nd, right around 11 o'clock p.m. D. Does the water ever reach a height of 6 feet? Take a close look at the top of the graph, and you see 6 feet. The highest point of the graph is just under 6 feet, so no, the water never reached 6 feet. Today's shout out goes to Carlsbad Promotions for their continued support on Patreon. Thank you, Carlsbad Promotions. 8th grade, Unit 5, Lesson 15, the volume of a cone. Problem number 1. A cylinder and cone have the same height and radius. The height of each is 5 centimeters and the radius is 2 centimeters. Calculate the volume of the cylinder and the cone. To calculate the volume of the cylinder, we'll multiply pi times r squared times the height. Since the height is 5 and the radius is 2, we'll multiply pi times 2 squared times 5, or pi times 4 times 5. 4 times 5 is 20. The volume of the cylinder is pi times 20 centimeters cubed. To find the volume of the cone, we'll multiply 1/3 times pi times r squared times height. Since the radius is 2 and the height is 5, we'll multiply 1/3 times pi times 2 squared times 5. And that's 1/3 times pi times 4 times 5. Or 1/3 times pi times 20. That can also be written as 20/3 times pi centimeters cubed. Problem number 2. The volume of this cone is 36 times pi cubic units. What is the volume of a cylinder that has the same base area and the same height? The formula for finding the volume of a cylinder is pi times r squared times height, and the formula for finding the volume of a cone is 1/3 times pi r squared times height. The above information tells us that the volume of the cone is 36 times pi cubic units. And the volume of a cone is 1/3 the volume of a cylinder. So the volume of the cylinder would be 3 times greater than the volume of the cone, or 3 times greater than 36 times pi. 3 times 36 is 108. So the volume of the cylinder would be 108 times pi, or 108 pi. Problem number 3 from 8th grade Unit 5, Lesson 14. A cylinder has a diameter of 6 centimeters and a volume of 36 pi centimeters cubed. A. Sketch the cylinder. This is what the cylinder would look like But now we need to use the information that they gave us to help us find the height and radius in centimeters, and then we'll be able to label the cylinder's height and radius. The volume of a cylinder is pi times r squared times the height. They've already told us that the volume is 36 pi centimeters cubed. They also told us that the diameter is 6 centimeters. Since the diameter is 6, then the radius has to be 3. Now we can substitute the 3 for the r. V equals 3 squared times the height times pi. 3 squared is 9. The volume equals 9 times the height times pi. 9 times h equals 36. So the height has to be 4 because 9 times 4 equals 36. Now we can label the height. The height is 4 and the radius is 3. Problem number 4 from 8th grade, Unit 5, Lesson 10. Lynn wants to get some custom t-shirts printed for her basketball team. Shirts cost $10 each if you order 10 or fewer shirts, and $9 each if you order 11 or more shirts. A. Make a graph that shows the total cost of buying shirts for 0 through 15 shirts. On the right side, you see I have a graph. The horizontal axis, or the x-axis, represents the number of shirts, and the vertical axis, or the y-axis, represents the cost in dollars. On the left-hand side, I have a table. The right side column of the table represents the number of shirts and correlates with the horizontal axis, or the x-axis, and the left-hand column represents the cost in dollars, which correlates with the vertical axis, or the y-axis. B. There are 10 people on the team. Do they save money if they buy an extra shirt? Explain your reasoning. If 10 people each paid $10 for one shirt, that would be 10 shirts for $100. If they bought an 11th shirt, then they could buy 11 shirts for $9 each, and 9 times 11 is $99. So if they paid for 11 shirts, they would actually save $1. C. What is the slope of the graph between 0 and 10? What does it mean in the story? The slope of the graph will be rise over run, and from 0 to 10, the rise is 100 and the run is 10. That's a slope of 100 divided by 10, or 10, so the slope is 10. That means it costs $10 to buy one t-shirt. D. What is the slope of the graph between 11 and 15? What does it mean in the story? The rise is 99 and the run is 11. That's 99 divided by 11, or 9. The slope in this section of the graph is 9. That means that it costs $9 to buy one t-shirt. Problem number 5 from 8th grade, Unit 5, Lesson 6. In the following graphs, the horizontal axis represents time, and the vertical axis represents distance from school. Write a possible story for each graph. For the graph on the left, the story could be that the student was at school, then started walking home, took a break for a while, and then continued walking home from school. For the next graph, the student started at school, walked all the way home, stayed at home for a while, and then walked back to school. For the third graph, the student started at home and then walked to school. Thanks again to Carlsbad Promotions for their continued support on Patreon. 8th grade, Open Up Resources, Illustrative Mathematics, Unit 5, Lesson 16, Finding Cone Dimensions. Problem number 1, from 8th grade, Unit 5, Lesson 15. The volume of this cylinder is 175 times pi cubic inches. What is the volume of a cone that has the same base area and the same height? The volume of a cylinder is 3 times greater than the volume of a cone. The volume of the cylinder is 175 units times pi, so the volume of the cone will be 3 times smaller than that. 175 times pi divided by 3 equals 58 1/3 times pi. Problem number 2. A cone has volume 12 times pi cubic inches. Its height is 4 inches. What is its radius? The formula for the volume of a cone is 1/3 times pi r squared times h. The information tells us that the volume is 12 times pi cubic inches. It also tells us that the height is 4 inches, so we can substitute the h with a 4, just like we substituted the v with a 12 times pi. Remember, the question says, what is the radius? That means that we're solving for r, so we're going to have to get the r all by itself on the right-hand side of the equal sign. Let's multiply both sides by the reciprocal of 1/3. That's 3. 12 times 3 times pi is 36 times pi, and 3 times 1/3 pi is 1 pi. On the right-hand side of the equal sign, it says 1 times pi r squared times 4. That's the same as 4 times pi r squared. Next, we can divide both sides by 4 pi. 36 pi divided by 4 pi is 9. And 4 pi r squared divided by 4 pi equals 1 r squared, or 9 equals r squared. Since 3 squared equals 9, r must equal 3. The radius of this cone is 3 inches. Problem number 3. A cone has volume 3 pi. Remember, the formula for the volume of a cone is 1/3 times pi times r squared times h. A. If the cone's radius is 1, what is its height? When the radius is 1, we can substitute the r with a 1. r squared, or 1 times 1, is 1. Since the information tells us that the volume is 3 pi, we can rewrite the equation as 3 pi equals 3 times 1/3 pi times 1 squared times h. Since we're solving for the height, we need to get the h by itself. Let's multiply both sides by the reciprocal of 1/3, which is 3. 3 times 3 pi and 3 times 1/3 pi times h. That gives us 9 times pi equals 1 times pi times h. And now we can divide both sides by pi. 9 times pi divided by pi equals 9, and 1 times pi times h divided by pi equals h. The height of this cone is 9 units. B. If the cone's radius is 2, what is its height? Since the radius is 2, we can substitute the r with the 2. Just like the first one, we're solving for the height. So let's multiply both sides by the reciprocal of 1/3, which is 3. 3 times 3 times pi is 9 times pi, and 3 times 1/3 pi is 1 pi. Now the equation reads 9 times pi equals pi times 2 squared times h. We can rewrite that as 9 pi equals 4 times pi times h. To get the h all by itself, we have to divide both sides by 4 times pi. 9 times pi divided by 4 times pi equals 9/4, and pi times h divided by pi equals h. The height of this cone is 9/4 units, or 2 1/4 units. C. If the cone's radius is 5, what is its height? So we can substitute the r with a 5, and we're solving for the height, so we're trying to get the height by itself. So again, let's multiply both sides by 3, which is the reciprocal of 1/3. 3 times 3 pi equals 9 pi, and 3 times 1/3 pi equals 1 pi, or pi. Now you can write the equation as 9 times pi equals 5 squared times pi times h. 5 squared, or 5 times 5, equals 25. So now the equation reads 9 pi equals 25 times pi times h. We're solving for the height, so we have to get the h by itself. Divide both sides by 25 pi. 9 pi divided by 25 pi equals 9/25, and 25 pi divided by 25 pi equals 1. 1 times h equals h. So h equals 9/25. When the radius is 5, the height of this cone would be 9/25 units. D. If the cone's radius is 1/2, what is its height? So now we can substitute the r with a 1/2. The equation reads 3 pi equals 1/3 pi times 1/2 squared times height. Since we're solving for height, we can multiply both sides by the reciprocal of 1/3, which is 3. 3 times 3 pi equals 9 pi, and 3 times 1/3 pi equals 1 pi, or pi. So now the equation reads 9 pi equals pi times 1/2 squared times height. 1/2 squared is 1/2 times 1/2, or 1/4. So the equation reads 9 pi equals 1/4 pi times h. Since we're solving for h, we need to multiply both sides by the reciprocal of 1/4, or divide both sides by 1/4. 9 pi divided by 1/4 pi is the same thing as 9 divided by 1/4, because the pi divided by pi cancels each other out. And pi canceled itself out on the right side of the equal sign as well. So now the equation reads 9 divided by 1/4 equals 1 times h. To solve that, we can multiply by the reciprocal of 1/4. And the reciprocal of 1/4 is 4, or 4 over 1. So 9 times 4 equals 36. That means that when the radius is 1/2, the height of the cone would be 36 units. E. If the cone's radius is r, then what is the height? This time we don't substitute the r with the number, we leave it an r. But we're still solving for height. So we can multiply both sides by the reciprocal of 1/3, and that's 3. So 3 times 3 times pi equals 3 times 1/3 times pi times r squared times height. 3 times 3 times pi is 9 times pi, and 3 times 1/3 is 1, so we have 1 times pi, or pi, times r squared times height. So remember, we're solving for the height. We can rewrite the equation as 9 pi equals r squared times pi times height. To get the h by itself, we can divide both sides by r squared times pi. 9 times pi divided by r squared times pi equals 9 over r squared. And on the right side of the equal sign, we have 1h. Now the equation reads 9 over r squared equals h. So when the radius of the cone is r, the height is 9 over r squared. Problem number 4 from 8th grade, Unit 5, Lesson 6. 3 people are playing near the water. Person A stands on the dock. Person B stands on the top of a pole and zip lines into the water. Person C climbs out of the water and up the zipline pole. Match the people to the graphs where the horizontal axis represents time in seconds and the vertical axis represents height above the water level in feet. This horizontal line represents person A standing on the dock, and it looks to me like the dock is approximately 10 feet above the water. This green line represents person B standing at the top of a pole and ziplining into the water. It looks like the pole was approximately 20 feet tall, then they ziplined into the water, and they actually went below the surface of the water, and then swam up back to the surface of the water, and walked out of the water onto the shore. That leaves us with person C. Person C climbs out of the water up the zipline pole. It doesn't really look like they're climbing up a zipline pole to me, but they are coming out of the water. It takes them a lot longer to climb out of the water than it did for them to zip line into the water. And that does make sense. Problem number 5, from 8th grade, Unit 5, Lesson 3. A room is 15 feet tall. An architect wants to include a window that is 6 feet tall. The distance between the floor and the bottom of the window is b feet. The distance between the ceiling and the top of the window is a feet. This relationship can be described by the equation a equals 15 minus b plus 6. A, which variable is independent based on the equation given? The value for a depends on what 15 minus b plus 6 is. So a is the dependent variable and b is the independent variable. B, if the architect wants b to be 3, what does this mean? What value of a would work with the given value for b? If the architect wants b to be 3, that means that the distance between the floor and the window is 3 feet. The value for a would be 6 feet if the value for b was 3 feet, because 6 equals 15 minus 3 plus 6. And 3 plus 6 is 9, so 15 minus 9 equals 6. A equals 6. That means that the distance between the top of the window and the ceiling would be 6 feet, when the distance between the bottom of the window and the floor is 3 feet. C. The customer wants the window to have 5 feet of space above it. Is the customer describing A or B? What is the value of the other variable? Well, first of all, the customer is describing A, the distance between the window and the ceiling. So we know what A is. That means we're solving for B. A is 5, so the equation reads 5 equals 15 minus B plus 6. So let's subtract 15 from both sides. 5 minus 15 is negative 10. Now the equation reads negative 10 equals 0 minus B plus 6. Negative times b is a negative b, and negative times a positive 6 is a negative 6. So negative 10 equals negative b minus 6. Add 6 to both sides. Now we have negative 4 equals negative b. Multiply those by a negative 1, and you have 4 equals b. So b equals 4. When the distance between the ceiling and the window is 5, the distance between the floor and the window is 4. 8th grade, Open Up Resources, Illustrative Mathematics. Unit 5, Lesson 17, Scaling One Dimension. Problem number 1. A cylinder has a volume of 48 pi centimeters cubed and a height h. Complete this table for volume of cylinders with the same radius but different heights. The table has a left-hand column with height in centimeters and a right-hand column of volume in centimeters cubed. The table starts out on the top with 1h, or 1 centimeter, and the volume is 48 pi, or 48 times pi, centimeters cubed. 2h, or 2 centimeter, would be double 1h, or double 1 centimeter. So the volume is going to be doubled. 2 times 48 pi equals 96 pi. This cylinder that's 2 centimeters in height has a volume of 96 pi centimeters cubed. The next cylinder has a height of 5h, or 5 centimeters. That's 5 times taller than the first cylinder. So we'll multiply 5 times 48 pi, and that equals 240 pi. The height of this cylinder is 5h, or 5 centimeters, and its volume is 240 pi centimeters cubed. The height of the next cylinder is h over 2, or half of h. That means it has half the height, or a half a centimeter. Since the height's only a half a centimeter, the volume of this cylinder will be half of 48 times pi. Half of 48 times pi, or 48 times pi divided by 2, equals 24 pi. So when the height is a half a centimeter, the volume is 24 pi centimeters squared. The height of the last cylinder is h over 5, or height divided by 5. That height is 5 times shorter than the original height, so the volume is going to be 5 times smaller than the original volume. 48 pi divided by 5. Since 48 pi divided by 5 is going to give us a mixed number, we can leave it as 48 pi divided by 5. So when the height of the cylinder is h over 5, the volume of the cylinder is going to be 48 pi over 5 centimeters cubed. Problem number 2. A cylinder has a radius of 3 centimeters and a height of 5 centimeters. A. What is the volume of the cylinder? To find the volume of a cylinder, you need to multiply pi times the radius squared times the height. Since the radius is 3 centimeters, we can substitute the r with 3. And since the height is 5 centimeters, we can substitute the h with a 5. Now the equation reads volume equals pi times 3 squared times 5. And 3 squared, or 3 times 3, is 9. So now the equation reads volume equals pi times 9 times 5. 9 times 5 is 45. So the volume of this cylinder is pi times 45 centimeters cubed, or 45 pi centimeters cubed. B. What is the volume of the cylinder when its height is tripled? The volume equals pi times r squared times height. The radius stayed the same, so if the height is tripled, we have to multiply the height times 3. The radius is 3 squared, or 3 times 3, which is 9, and the height is 5 times 3 because it's tripled. 9 times 5 times 3 equals 135. So the volume of this cylinder is 135 pi centimeters cubed. C. What is the volume of the cylinder when its height is halved? In other words, what is the volume of a cylinder when the height is half of 5 centimeters? If we cut the height in half, half of 5 centimeters is 2.5 centimeters. So we can substitute the h with a 2.5. The r is still a 3, and 3 squared is 9. 9 times 2.5 equals 22.5. The volume of the cylinder when its height is cut in half is 22.5 pi centimeters cubed. Problem number 3. A graduated cylinder that is 24 centimeters tall can hold 1 liter of water. What is the radius of the cylinder? What is the height of the 500 milliliter mark, the 250 milliliter mark? Recall that 1 liter is equal to 1,000 milliliters. Here's a graduated cylinder. Imagine its height is 24 centimeters tall, and it holds 1 liter of water. That means its volume is 1 liter, which is also equal to 1,000 milliliters. So we can say that its volume is 1,000 milliliters. We can rewrite the formula as 1,000 equals pi times r squared times 24, because the volume is pi times r squared times the height, and the height is 24, so we substitute the h with a 24. Since we need to find the radius, we're going to divide both sides by pi times 24. On the right-hand side, pi times r squared times 24 divided by 24 times pi leaves us with r squared. That's why we did it. Now on the left-hand side, we also have to divide the 1,000 by 24 times pi. And 1,000 divided by 24 times pi equals 13 and 27 hundredths. So the radius squared equals 13 and 27 hundredths. What number times itself equals 13 and 27 hundredths? 3.64. So the radius of this graduated cylinder is 3.64 centimeters. This question also asks, what is the height of the 500 milliliter mark? Well, 500 milliliters is half of 1,000 milliliters, so its height is going to be half of 24 centimeters. Half of 24 centimeters is 12 centimeters. That was the easy way. We could have substituted the v with 500 and then figured out the height by solving for h. Divide both sides by 13.27 times pi, and h equals 12, or 12 centimeters. They also ask, what is the height of the 250 milliliter mark? Well, I know that 250 is half of 500, so we can just cut the 12 centimeters in half and get 6 centimeters. Or we can substitute the v with 250, solve for h, or solve for the height, by dividing both sides by 13.27 times pi. And we see that the height is 6. The height is 6 centimeters. Problem number 4 from 8th grade, Unit 5, Lesson 16. An ice cream shop offers 2 ice cream cones. The waffle cone holds 12 ounces and is 5 inches tall. The sugar cone also holds 12 ounces and is 8 inches tall. Which cone has a larger radius? The volume for both cones is 12 ounces. Since they both hold the same amount of ice cream or have the same volume, the shorter cone will have the larger radius. The taller cone will have the smaller radius. So the waffle cone has a larger radius. Problem number 5 from 8th grade, Unit 5, Lesson 15. A 6-ounce paper cup is shaped like a cone with a diameter of 4 inches. How many ounces of water will a plastic cylindrical cup with a diameter of 4 inches hold if it is the same height as the paper cup? The 2 cups have the same diameter, which means they have the same radius. A cylinder with the same diameter and the same height holds 3 times the amount as a cone. It tells us that this cone holds 6 ounces of water. So that means that the cylinder is going to hold 3 times that. So the volume of the cylinder is 18 ounces because 6 times 3 is 18. Problem number 6 from 8th grade, Unit 5, Lesson 9. Lynn's smartphone was fully charged when she started school at 8 a.m. At 9:20 a.m. it was 90% charged, and at noon it was 72% charged. A. When do you think her battery will die? Let's make a chart with time on the left and percent charge on the right. At 8 a.m. it was 100% charged or fully charged. Then again at 9:20 a.m. it was 90% charged. And then finally at noon it was 72% charged. From 8 a.m. to 9:20, an hour and 20 minutes passed and the phone lost 10% of battery. From 9:20 to 12, 2 hours 40 minutes passed and it lost 18% of battery. At this rate, if another 2 hours and 40 minutes passed, it would be 2:40 p.m. and let's say the battery lost another 18%. Then 54% of the battery would be charged. 2 hours and 40 minutes later at 5:20 p.m., the battery charge would be at 36%. And 2 hours and 40 minutes after that, it would be 8 o'clock p.m. and the battery life would only be 18%. And then finally, another 2 hours and 40 minutes later at 10:40 p.m., the last 18% would drain out of the battery. So this is an approximation, so I'd say approximately 10:40 p.m., the battery would have 0 charge. B. Is battery life a function of time? If yes, is it a linear function? Explain your reasoning. Yes, the battery life is a function of time. However, it is not a linear function. It took 80 minutes for her to lose the first 10% of the battery, and then it took another 160 minutes for her phone to lose another 18%. If the function were linear, it would lose exactly twice as much in 160 minutes as it did in 80 minutes. The example that I created was fairly linear, but not quite linear. 8th grade, Open Up Resources, Illustrative Mathematics. Unit 5, Lesson 18, Scaling 2 Dimensions.
Problem number 1. There are many cylinders with a height of 18 meters. Let R represent the radius in meters and V represent the volume in cubic meters. A. Write an equation that represents the volume, V, as the function of the radius, R. We can start out using the formula for finding the volume of a cylinder. V equals pi times R squared times height. Since we're talking about cylinders with a height of 18 meters, we can substitute the h with an 18. We can also rewrite this as V equals 18 times pi times R squared, or V equals 18 pi R squared. B. Complete this table, giving 3 possible examples. In the table, they have a 1 representing the radius. So in our equation, we need to substitute the R with a 1. Now the equation reads V equals pi times 1 squared times 18, which is equal to V equals 18 times pi, or V equals pi times 18. When the radius is 1, the volume is 18 times pi. For the next row in the example, let's use 2. So now we can substitute the R with a 2. V equals pi times R squared times 18. 2 times 18 equals 72. So when the radius is 2, the volume is 72 times pi. For this last example, let's use a 5 as the radius. So we'll substitute the R with a 5. V equals pi times 5 squared times 18. 5 times 18 is 450. When the radius is 5, the volume is 450 pi. C. If the radius of a cylinder is doubled, does the volume double? Explain how you know. Let's go back to the table and change out the radius 5 and make it a radius of 4. Because a radius of 4 is double a radius of 2. V equals pi times 4 squared times 18. That's the same as V equals 288 pi. So when the radius is 4, the volume is 288 pi. Let's go back to the chart and look at the volume when the radius is 2. Doubling 72 would give you a volume of 144. But as you can see here, when you double the radius of 2, you have a volume of 288 times pi. So I would say no. D. Is the graph of this function a line? Explain how you know. I've graphed these 3 points on a line, and as you can see, they do not form a straight line. Problem number 2, from 8th grade, Unit 5, Lesson 3. As part of a competition, Diego must spin around in a circle 6 times, and then run to a tree. The time he spends on each spin is represented by S, and the time he spends running is R. He gets to the tree in 21 seconds after he starts spinning. A. Write an equation showing the relationship between S and R. 6 spins plus 1 run equals 21 seconds total. That can be written as 6S plus R equals 21. B. Rearrange the equation so that it shows R as a function of S. That means that we rewrite the equation as if we were solving for R. In order to move the 6S over to the other side of the equal sign, we have to subtract 6S from both sides. That would be R equals 21 minus 6S, or R equals negative 6S plus 21. C. If it takes Diego 1.2 seconds to spin around each time, how many seconds did he spend running? To solve this, we have to substitute the S with 1.2 seconds. That means that we need to multiply -6 times 1.2 seconds. -6 times 1.2 seconds is -7.2. 21 seconds minus 7.2 seconds equals the running time. The running portion would have taken 13.8 seconds. Problem number 3 from 8th grade, Unit 5, Lesson 7. The table and graph represent two functions. Use the table and graph to answer the questions. A. For which values of x is the output from the table less than the output from the graph? On the table, when x is 1, y is 3. And on the graph, when x is 1, y is a little bit more than 2. I'd say no for this one because the table has a higher output than the graph. On the table, when x is 2, y is -1, but on the graph, when x is 2, y is almost +4. Yes, this one, the table output is less than the output on the graph. For the next one, in the table, when x is 3, y is 0, but on the graph, when x is 3, y is just a little bit less than +4. Yes, this one, the table output is less than the output on the graph. Let's look at the next one in the table. When the value for x is 4, the value for y is 4. Now let's look at the graph. When the value for x is 4, the value for y is a little bit more than 2. I'd say no for this one because the table has a higher output than the graph. Let's look at the table again. When the value for x is 5, the value for y is also 5. Now let's look at the graph. When the value for x is 5, the value for y is 0. This is also a no because the value for y in the table is greater than the value for y on the graph. Last one. Let's look at the table. When the value for x is 6, the value for y is -1. Now let's look at the graph. When the value for x is 6, the value for y is between -2 and -3. This one is also a no because the value for y in the table is -1, which is greater than the value for y on the graph, which is somewhere between -2 and -3. B. In the graphed function, which value of x gives an output of 0? On the graph, I can see 3 locations where the output or y value is 0. When the value for x is 0, the value for y is 0. When the value for x is 5, the value for y is 0. And when the value for x is 10, the value for y is 0. So at x values 0, 5, and 10, the output or y value is 0. Problem number 4. A cone has a radius of 3 units and a height of 4 units. A. What is the volume of this cone? Let's start with the formula. Volume of a cone equals 1/3 times pi times r squared times height. They've given us the radius and the height, so we can substitute the radius with a 3 and the height with a 4. Now the equation reads volume equals 1/3 pi times 3 times 3 times 4. Since order doesn't matter in multiplication, we can look at this as 1/3 times 3 times 3 times 4 times pi, or 12 times pi. So the volume of this cone is 12 pi. B. Another cone has quadruple the radius and the same height. How many times larger is the new cone's volume? When you quadruple 3, you get 12. So we're going to substitute the r with a 12. Now the equation reads v equals 1/3 pi times 12 squared times 4, which is 1/3 times pi times 12 times 12 times 4. And again, because the order doesn't matter in multiplication, we could look at this as 1/3 of 12 times 12 times 4 times pi. And 1/3 of 12 is 4. So the equation could read volume equals 4 times 12 times 4 times pi. Or the volume is
192 times pi. How many times larger is the new cone's volume? Let's take the new volume and divide it by the old volume. 192 times pi divided by 12 times pi. Since 12 goes into 192 16 times, the new volume is 16 times greater than the old volume.
Eighth grade, Open Up Resources, Illustrative Mathematics. Unit 5, Lesson 19, Estimating a Hemisphere. Problem number 1. A baseball fits snugly inside a transparent display cube. The length of an edge of the cube is 2.9 inches. Is the baseball's volume greater than, less than, or equal to 2.9 to the third power cubic inches? Explain how you know. The baseball's volume is less than the cube's volume. The baseball fits inside the cube, and the cube's volume is 2.9 cubic inches. Since the cube's volume is 2.9 cubic inches, and the baseball fits inside the cube, the baseball's volume has to be less than the cube's volume. Problem number 2 from 8th grade, Unit 5, Lesson 18. There are many possible cones with a height of 18 meters. Let R represent radius in meters and V represent volume in cubic meters. A. Write an equation that represents the volume, V, as a function of the radius, R. We can start with the formula for finding the volume of the cone, and that is V equals 1/3 times pi times R squared times H. They tell us that the height is 18 meters, so we can substitute the H with an 18. Now the equation reads V equals 1/3 pi R squared times 18. Remember, when multiplying, the order doesn't matter, so we can find 1/3 of 18. 1/3 of 18 is 6, so now the equation reads V equals 6 times pi R squared. This equation represents volume as a function of the radius, because the volume depends on the size of the radius. B. Complete this table for the function, giving 3 possible examples. Remember, we're going to use the equation V equals 6 times pi times R squared. So if the radius is 2, we'll substitute the R with a 2. Now it reads V equals 6 times pi times 2 squared. 2 squared is 4, and the order doesn't matter, so we can do 6 times 4 times pi. Now the equation reads V equals 24 pi. When the radius is 2, the volume is 24 pi. For the next one, we'll use 4 as the radius. So the volume is going to be 1/3 of 18, which is 6, times pi times 4 squared. 4 times 4 is 16. 6 times 16 times pi. When the radius is 4, the volume is 96 pi. Let's do one more. When the radius is 8, the equation would read volume equals 1/3 of 18, which is 6, times pi times 8 squared. 8 squared is 8 times 8, or 64. Remember, the order doesn't matter in multiplication, so we can multiply 6 times 64 times pi. When the radius is 8, the volume is 384 times pi. C. If you double the radius of a cone, does the volume double? Explain how you know. The easiest way to tell is to look at the table. Let's look at the radius of 2 and double it. That becomes 4. Now let's look at the volume of the cone with a radius of 2. That's 24 times pi. And if you double 24 times pi, you'd have 48 times pi. But the volume of the cone with a radius of 4 is 96 times pi. And that's actually 4 times bigger than 24. When you double the radius of a cone, you quadruple the volume of the cone. D. Is the graph of this function a line? Explain how you know. The graph of this function is not a line because if you plot the 3 points from the table, they will not form a straight line. Problem number 3. A hemisphere fits snugly inside a cylinder with a radius of 6 centimeters. A cone fits snugly inside the same hemisphere. A. What is the volume of the cylinder? On the right-hand side, there's a picture of a cylinder. In the middle, there's a picture of a sphere. So remember, this sphere fits snugly inside this cylinder. On the left-hand side, we have a cone, and the cone fits snugly inside the sphere. That means that the radius of this cone has the same radius as the sphere. Remember, the formula for the volume of a cylinder is V equals pi times r squared times height. And since the radius of the cylinder is 6, we can substitute the r with a 6. Since the radius of the sphere is 6, the height of that sphere is also 6. And since it fits snugly inside the cylinder, that means that the height of the cylinder must be 6. So we can substitute the h with a 6. Since the order doesn't matter in multiplication, we can multiply the 6 squared, or 6 times 6, times 6. That gives us 216. So the equation now reads, the volume equals 216 pi centimeters cubed. B. What is the volume of the cone? The volume of a cone is 1/3 the volume of a cylinder with the same radius and the same height. So the formula is volume of a cone is 1/3 pi r squared times height. So the volume of this cone is going to be 1/3 of 216 times pi centimeters cubed. And 1/3 of 216 is 72. So the volume of this cone is 72 times pi centimeters cubed. C. Estimate the volume of the hemisphere by calculating the average of the volume of the cylinder and the cone. To find the average, we'll just add 216 plus 72, and that's 288. 288 divided by 2 is 144. So the estimated volume of the sphere is 144 centimeters cubed. Problem number 4. A. Find the hemisphere's diameter if its radius is 6 centimeters. The radius is the distance from the center outwards. The diameter goes straight across the circle through the center. If its radius is 6 centimeters, then the diameter is going to be 12 centimeters. B. Find the hemisphere's diameter if its radius is 1,000 over 3 meters. Double the radius is 2,000 over 3 meters. So the diameter would be 2,000 over 3 meters. C. Find the hemisphere's diameter if its radius is 9.008 feet. Double the radius is 2 times 9.008, and that equals 18.016 feet. So the diameter is 18.016 feet. D. Find the hemisphere's radius if its diameter is 6 centimeters. The radius is half the diameter. If the diameter is 6 centimeters, then the radius is 3 centimeters. E. Find the hemisphere's radius if its diameter is 1,000 over 3 meters. The radius is half the diameter. If the diameter is 1,000 over 3, then half of 1,000 over 3 is 500 over 3. The radius would be 500 over 3 meters. F. Find the hemisphere's radius if its diameter is 9.008 feet. The radius is half the diameter. Half of 9.008 is 4.504. The radius is 4.504 feet. Problem number 5 from 8th grade, Unit 5, Lesson 9. After almost running out of space on her phone, Elena checks with a couple of friends who have the same phone to see how many pictures they have on their phones and how much memory they take up. The results are shown in the table. A. Could this information be reasonably modeled with a linear function? Explain your reasoning. To get the unit rate, divide 8,072 by 2,523. Since the number of photos divided by the memory used equals 3.2 in all three situations, then yes, this is a linear function. The constant of proportionality is 3.2. So you need 3.2 megabytes to have one photo. The rate of change is 3.2, and that is the slope for a linear function. We can write the equation as m equals 3.2 p. B. Elena needs to delete photos to create 1,200 megabytes of space. Estimate the number of photos she should delete. This is where we can use the equation m equals 3.2 p. Substitute 1,200 for m, and it reads 1,200 equals 3.2 p. Divide both sides by 3.2. 375 equals 1 p. She needs to delete about 375 photos to create 1,200 megabytes of space. Eighth grade Open Up Resources, Illustrative Mathematics, Unit 5, Lesson 20, The Volume of a Sphere. Problem number 1. Match the description of each sphere to its correct volume. Sphere A, radius of 4 centimeters. We can substitute the r with a 4, and we can rewrite it as 4 to the 4th power over 3 times pi. Since 4 to the 4th power equals 256, we can rewrite it as 256 over 3 times pi. Sphere A matches volume number 2. Sphere B, diameter of 6 centimeters. Okay, since the diameter is 6 centimeters and the radius is half the diameter, we can substitute the r with half a 6, or substitute the r with a 3. 4 divided by 3 times 3 cancels each other out, so we can rewrite this as 3 to the 2nd power, and 3 to the 2nd power is 9. Now it can be rewritten as v equals 4 times pi times 9, which equals 36 times pi. That makes the volume 36 times pi centimeters cubed. Sphere B matches volume 3. Sphere C has a radius of 8 centimeters, so we can substitute the r with an 8. 4 times 8 to the 3rd power equals 2,048. Sphere C matches volume 4. Sphere D has a radius of 6 centimeters, so we can substitute the r with a 6. 4/3 times pi times 6 to the 3rd power equals 288 times pi. Sphere D matches volume 1. Problem number 2. A. A cube's volume is 512 cubic units. What is the length of its edge? To find the volume of a cube, you have to multiply the side length by itself 3 times. So what number times itself 3 times equals 512? 8 times 8 times 8 equals 512. So the side length is 8 units. B. If a sphere fits snugly inside this cube, what is its volume? If the side length of this cube is 8, then the radius of the sphere would be 4. We can substitute the r with a 4. 4 times 4 to the 3rd power is 256, so we can rewrite this as 256 over 3 times pi. So the volume of that sphere would be 256 over 3 times pi. Units cubed. C. What fraction of the cube is taken up by the sphere? What percentage is this? Explain or show your reasoning. The volume of the cube is 512. So the volume of the sphere divided by the volume of the cube is the fraction that represents the space taken up by the sphere.
The volume of the sphere is 256 over 3 times pi, and the volume of the cube is 512. Since we're dividing fractions, we're going to multiply by the reciprocal of 512. 256 divided by 3 times pi times 1 over 512 equals pi divided by 6, or pi over 6. And pi divided by 6 equals 52%. The percentage of the cube taken up by the sphere is 52%. Problem number 3. Sphere A has radius 2 centimeters. Sphere B has radius 4 centimeters. A. Calculate the volume of each sphere. Substitute the r with a 2. And for sphere B, substitute the r with a 4. 2 to the third power is 8, and 4 to the third power is 64. The volume for sphere A is 32 over 3 times pi centimeters cubed, and the volume for sphere B is 256 over 3 times pi centimeters cubed. B. The radius of sphere B is double that of sphere A. How many times greater is the volume of sphere B? The volume of sphere B divided by the volume of sphere A. Remember, when we're dividing fractions, we're really multiplying by the reciprocal of the second fraction. Here we can cross cancel. 3 goes into 3 once, 3 goes into 3 once, 32 goes into 32 once, and 32 goes into 256 8 times. 8 times 1 is 8. Sphere B has a volume that's 8 times greater than sphere A. Problem number 4 from 8th grade, Unit 5, Lesson 16. 3 cones have a volume of 192 pi centimeters cubed. Cone A has a radius of 2 centimeters. Cone B has a radius of 3 centimeters. Cone C has a radius of 4 centimeters. Find the height of each cone. We know that the sum of the volume for all 3 cones is 192 pi centimeters cubed. We can start by substituting the r with the radius of each of the 3 cones. Cone A has a radius of 2, cone B has a radius of 3, and cone C has a radius of 4. To find the missing height for each cone, we can set it up like this and solve for h. The height for cone A is 144 centimeters, cone B is 64 centimeters, and cone C is 36 centimeters. Problem number 5 from 8th grade, Unit 5, Lesson 5. The graph represents the average price of regular gasoline in the United States in dollars as a function of the number of months after January 2014. A. How many months after January 2014 was the price of gas the greatest? 5 months after January 2014, the price of gas was the greatest. B. Did the average price of gas ever get below $2? This horizontal line represents $2, and as you can see, there was one time when gas went below $2, so the answer is yes. During the 24th, 25th, and 26th months after January 2014, the gas price dipped below $2. C. Describe what happened to the average price of gas in 2014. The average price of gas rose from January to May. Then, the average price of gas decreased the rest of the year. Problem number 6 from 8th grade, Unit 4, Lesson 15. While conducting an inventory in their bicycle shop, the owner noticed the number of bicycles is 2 fewer than 10 times the number of tricycles. They also know there are 410 wheels on all the bicycles and tricycles in the store. Write and solve a system of equations to find the number of bicycles in the store. They told us that the number of bicycles equals 2 fewer than 10 times the number of tricycles. I'll use B for bicycles and T for tricycles. B equals 10 times T minus 2. This equation represents the number of bicycles being equal to 2 fewer than 10 times the number of tricycles. The information also tells us that there's 410 wheels on all bicycles and tricycles. We can write this equation as 410 equals 2b plus 3t. We can use these two equations in our system of equations to find the number of bicycles in the store. Since b equals 10t minus 2, we can substitute b with 10t minus 2. Now the equation reads 410 equals 2 times 10t minus 2 plus 3t. Using the distributive property, we know that 2 times 10t equals 20t, and 2 times the negative 2 equals negative 4. 410 equals 20t minus 4 plus 3t. 20t plus 3t is 23t. Bring down the minus 4. Now we can add 4 to both sides. 414 equals 23t. Divide both sides by 23, and we have t equals 18. The store has 18 tricycles. Since the store has 18 tricycles, we can substitute the t with an 18. The number of bicycles equals 10 times 18 minus 2. 10 times 18 is 180, and 180 minus 2 is 178. There's 178 bicycles in the store.